concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grafing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody? All right, it is Monday, new week.
That's dope.
It's actually technically a holiday today for the United States people. I don't know, a lot of people don't have school today. It's a 3-day weekend. Nice. Plus, I think the banks are closed, but I know we have a lot of people from Canada on our stream, and I don't think you guys have today off, unfortunately. What's up, Rainy? Good to see you, dude. Welcome all the way from Egypt, right? You're in Egypt, Rainy? Yeah? I hate this crease in my green screen. Oh, go away. It's kind of away. Okay, I like it. All right, there you go. I have a holiday tomorrow because of inclement weather. Oh, that's dope. Yeah, the East Coast has been getting battered by snowstorms recently. I was watching the Eagles game. My neighbors are really big Philly fans for the NFL games, and so I've been like adopted by them. And I went and I watched the game in Philadelphia, or I watched the game that's being played in Philadelphia. I was not in Philadelphia, but oh my god, this thing looked like a snowstorm. It was crazy. Let's look at this. Yeah, look at this. Just like blizzards. Just nuts. You can't even see, couldn't even see the field, honestly. I don't know how they're seeing the ball or anything. Snow day. You all had holidays. Really, is Canada just getting really messed up? What's up, Messi? Messi's the best. What's this? There's always this debate between Messi or Ronaldo, right? Which one's better? It isn't that bad, Canada, but we had less snow than usual, but we still got a holiday. Oh, that's cool.
Good job.
Good job, weather. Is it really that bad? Just curious. I mean, that's cold. 12 degrees? Excuse me? Well, I guess this is like all of Canada. Let's say Toronto. I have a friend that just went to Toronto for the week. Yeah, that's still cold. Oh, okay. What's up, Ryan? Good to see you, dude. Recky Rex says, that's nothing, dude. It's like, this is weak sauce. Dude, oh my god, look at all, what? Single digits? 1 degree? That's a no from me, dog. Sips maple syrup. I do love the maple syrup there. Wait, I want to see, is there... Oh, polar vortex. That's what they're calling it. Toronto will feel like -20? Jeez. That is cold. Yeah, no, at some point, you start worrying about, like, frostbite. If any of your skin is exposed for, I don't know, like a couple minutes there, you get frostbite, don't you? No snowman this year. They were making snow people, what was it? I'm trying to think. Where would this be? This be on my Instagram, maybe? I gotta remember which account this is on. I think it was here. One second, let me find it. Yeah, this was it. Yeah, look at this. They were so this was the game I watched. It was the Eagles from Philadelphia against the Rams, LA, which is where I live. But so it's kind of interesting for me to be rooting for not my home team. But this was in Philadelphia, super snowy and whatnot. But look at this
season,
they were making snow angels in the end zone.
Enjoying their snow angel moment. By Williams, 3 in the
Snow
regular.
angels, like what the hell, dude? That's too crazy. You're looking old, Goldilocks. Thanks, Rand. I do look older. Yeah, this is the aging process. Yeah, I mean, Rand's been with us since, oh, I don't know. We've been here 3-4 years. Wow. Thanks, Laz. Oh, the subscription. Sweet. Thank you, Laz. Appreciate the subs. Raven, why snow? Why no snowmen this year? Are you living somewhere there's not snow? Rand has been here since 2021. Yeah, so almost 4 years. Yeah. So I have aged a lot in 4 years. I don't know. Also, just like life has gotten very lifey in the last 4 years. I feel like this whole last 5 years has been 20. Just because, I don't know, we dealt with COVID, right? And then now I just had to deal with like the wildfires too and everything. That's just too much going on. Imagine if Texas got 1 inch of snow, the whole state would shut down. They do actually, Shantrix. Funny that you say that. I'm from Texas, but when we did have that big freeze, I think it was last year, or yeah, it was last year, right? The houses aren't built for cold weather, so they're not insulated at all or anything. So all the pipes started bursting. And the reason why the pipes burst is actually a cool thing. It's a physics concept. Chemistry as well, I guess. But water has a lower density when it's solid than when it's liquid. And so what happens is the liquid water in the pipes freezes and then expands. And that causes the pipe it's in to break. So, not a good thing. And that's why Houston, my hometown where I'm from, had all these houses just leaking water everywhere. Just because it got slightly below freezing for a day or two, and that messed up a lot of stuff. Lowest density is at 4 degrees Celsius. You're right. It does do this weird thing where, you're right, liquid water... Wait, lowest density? Is it at 4? Did I get affected by the fires? I just had to evacuate for a little bit. But no, nothing got damaged. Maybe my lungs. Maybe. I don't know. Let's see. Density of liquid water with temperature. Yeah, this is what I wanted to see. There is... You are right. The highest density, I think, is at 4. Not the lowest. The lowest... Yeah, your brain is not raining. It's okay, dude. Yeah. You're still good, dude. Yeah, it has to do with this. Because, yes, as things get colder, they usually get more dense because the atoms stop vibrating as much. Temperature is related to how fast atoms are vibrating. And if they're not moving around very much and they're staying close together, then that causes things to look more compact and more dense. The weird thing with water, though, is the second it starts going to turn to ice expands due to this lattice crystal structure that it makes when water becomes ice. And so the density drops. Most things don't do that. Most things, any other liquid, honestly, if you freeze it, it gets more dense. Peak density, yes. What's up, Phobos? It is... El Cato. What? Is Messi speaking in reverse, dude? What is this? Which is why ice cubes float on water. Yes. And I've been over this before. We actually need water to be less dense as ice than... Sorry, for whatever. Yeah, for H2O to be less dense as ice than as liquid water. Because otherwise, we'd all be dead. There's a nice little graph of this. What is it? I'm looking for ice, water, barrier, something like this. No, ice, water, barrier, but with a lake. And like, ice less dense than water, lake, diagram. I don't know. I'm looking for it. Oh, Croatian. Oh, that's Croatian? That's not... Raven Violet. Oh, Dockle seat. Oh, what you're saying is Croatian. Oh, that's cool. Yeah, it has to do with this. Where is it? Is this the image I'm looking for? Yeah. There we go. Yeah. So in the winter, it's nice to have the ice because the ice protects all the things below the ice in the lake from dying. Because if ice was more dense, this ice would sink. And then more ice would form on top of it. And then this would just continue until the whole lake was ice. And then nothing would live more than a year in a lake, which would be bad. So ice floating is actually really helpful because it forms a barrier on the top that keeps the water underneath from continuing to freeze. Yeah. E to the 2i pi. Yeah, what's up? Are you a member amongst Penn Center's Discord? I am. I guess I'm technically a mod on Penn Center's Discord, but the Balkans have raided your stream. It's okay. I appreciate all the worldwide stuff. It's very cool. Yes, ecosystems, algae and other plants. Yes, exactly. Yeah. Shentrix brings up a good point. A lot of the oxygen that we breathe is from, algae and ocean plants. Yeah. We think it's all trees, but I think a lot of it is also from the algae. It's a big proportion of it. But yes, Neil. Yeah, I am. We love Penn Center. He's a great guy. Are they still streaming today? I checked in their stream earlier at like 11, but it's been almost 3 or 4 hours since then. They're doing a linear algebra course, which is really cool. If you ever want to check out what's going on with all our other fun math streamer friends, we have a whole calendar for it. It's really cool. Let's see. Yeah, no, they were much earlier. This was Penn Center was doing this. Yeah, big shout out to Penn Center. Penn Center's a great guy. We like Penn Center. He's not in the stream right now, but it'll shout him out anyways. Yeah, there we go. Trees is like 30%. Oh, that's actually a good question. Let me say percentage of oxygen created by algae. Let's just see. Wow. Photosynthesizing algae in the ocean produces 70% of the oxygen in the atmosphere? I didn't know that. That's a really cool fact, Shantrix. Yeah. So what Shantrix is saying is that, most of the oxygen in the world is produced by algae in the ocean. This is also why, if the ocean temperatures start changing a lot, that messes up the algae, and then the algae doesn't produce oxygen, and then we all die. So that would be bad. Yeah. Yeah, cool.
If it goes really wrong and it produces too much oxygen, we all freeze to death.
Yeah, I guess if we had global cooling, that would be bad too, right?
Because if it adapts to the higher temperatures and produces more oxygen.
Oh, I see. If it produces
and then
more.
attempts to adapt, then it produces too much oxygen, then we all die because it freezes.
So then we have we don't have hypoxia, we have hyperoxia, or what was that called? Hypo and hyper. Hyperoxia. Yeah, that is pretty cool. Yeah, and the world we live in is a very fragile simulation of things, and there's all these moving parts that are doing things. And when we tend to mess up one of the moving parts, it tends to screw up all the other parts. Which is bad. So, getting ready for the ice age. There is an interesting graph actually about the world temperature. I saw this at one point. What was it? World temperature history, something like this. It's yes, it has spiked a lot, but if we look at the big picture, this is where, again, I'm not a climate denier. I do believe that we are fucking up the climate with things, but if you look at the global temperature over the last 500 million years, it's actually interesting. So average global temperature right now is around, I guess, right now it's in the upper 60s, I guess, low 60s or something, but here, and they say world with polar ice caps. So this is the cutoff. So the cutoff is whenever the global temperature, I guess, goes above 67. That's when we lose all the ice in the polar caps. So for a lot of time here, the Earth was very hot. I wonder why this was, actually, because it's not like the Earth was getting closer or further away from the sun. I should get some climate person on one of my podcasts to explain this to me, because I'm curious about this.
The high levels of carbon dioxide.
You're right. But why? So what? We needed a lot of algae but why was it really cold 350 million years ago, and then it was really hot 250 million years ago? Why does it keep swapping so much?
Well, it's huge periods of time. So we're talking about algae producing a lot of oxygen and the Earth basically freezing. And then we're talking about huge mammals that just take in vast amounts of oxygen. And you basically use it all up.
Yeah. Oh, I see. So, I see. That's the cycle, and then things die.
And then, of course, sorry. Then you've got to add in volcanic activity.
Yeah, Shantrick says this. Mega volcanoes.
Huge coal fires like the size of Russia go off.
Oh, dear.
That's even more carbon dioxide.
Disqualified.
That's not good, dude. Yeah.
Basically, the landmass of current day Russia was on fire at one point.
Oh, damn. Is your microwave on fire too? I heard it beeping.
Not me.
Not me. Yeah. So I mean, I guess this is the scary part over here. They talk about this. They say that there's been a massive increase just in the last 50 or 100 years. We've seen this huge increase. But on the large scale of things, we're actually pretty cool. We're pretty chill right now. We used to be really hot. I guess it was too hot for, they say, equatorial Pangea, too hot for peat swamps. I forget when life as itself started. Do you know when that was? When did life start on Earth?
The Cambrian explosion?
They say 3.7 billion years ago. Excuse me? What? So, I mean, that's weird things like microbial structures. Okay, let's say, when did mammals...
complex life.
Let's say mammals. When did mammals first appear? Okay, mammals first started with these little rat-looking creatures 225 million years ago. Okay, so if we look at our graph, right, 225 million years ago, that's around here. So at least the rats could still survive when the world was this hot. Right? Maybe humans is a little bit different.
I was looking at the graph.
Sharks are older than trees? Oh, yeah. Turtles are very old too, right? When did the first...
trees are older than the bacteria that eats them.
Okay, did we come from chimps or gorillas? I forget. Chimps, right?
Neither.
Are you gonna argue we came from God or something, dude?
No. Chimps, gorillas, and us have a common ancestor, but they're not the same thing.
Oh, interesting. So it's... okay. Homo
Chimps
and
gorillas became from our common ancestor.
Okay.
We didn't come from... We came from a gorilla-like or chimp-like creature.
Oh, a gorilla-like, chimp-like creature. Okay, I see. So, okay, the earliest hominin, which is primal bipedalism. Cool. So bipedalism means on 2 feet, was 6 to 7 million years ago. So on this graph, yeah, that's definitely in the cool period, is what that is. Okay. So maybe we lose that if we go above this line. Uh-oh. I don't know.
Well, I mean, even if you don't believe in climate change, we are still pumping unnatural amounts of carbon dioxide into the atmosphere.
Correct. I agree with that. Yeah.
Unnatural being the operative phrase there as well, because it just, all of that has happened naturally. It's gone now. There's no more surface coal.
Right. There's no more because we've already burned all of it. We've burned all the surface coal at this point.
Well, no, because we have to start digging down for it.
Sure. Right. Exactly. I guess this is a cool graph, and it's also it looks like they start. So this goes back 65 million years ago, right? We said 7 is when humans or two-footed things. Yeah, but this is the issue, I guess, is right here, is because they're predicting, and this is what man, the predictions are always so wild, man. This is probably some algorithm. This is another algorithm. This is another algorithm. This is another algorithm, and it either does this, or this. So, I don't know. It doesn't have an actual name. Oh, okay, cool. He's talking about this. This is our human last common ancestor. Okay, cool. Nice. I learned a little bit today. That's cool. No, we didn't do any questions yet, Ace. Sorry, we just started the stream. Anyways, someone was asking earlier in the stream. Who was it? Fat Man. Yeah, Fat Man. If you need help with Diffie Q or physics, we do that. We love that.
Oh, you were talking about me.
I do. I feel like a fat man, honestly. I said I would start my diet tomorrow.
Did I tell you?
What's up?
I'm only 5'5".
Okay.
But I weigh 17 stone now.
Okay. Is that a lot?
220, 230.
240. Oh, you are a large individual, Sensation. You are a big man.
Interestingly enough, not as fat as some people that are a lot taller and a lot skinnier, a lot less weight.
Yeah, dude. What's this guy? This rapper, Dave Blunts or something? Do you guys know what I'm talking about? One sec. I got him somewhere in here. I sent it to one of my friends. I was like, yeah. What's this guy? This poor guy. Who did I send it to? Oh, I sent it to my other account. One sec. Da-da. And then we'll start questions here soon. Don't worry.
What is older, egg or chicken? Egg.
Yeah, what came first, the chicken or the egg?
Well,
I think the egg came first. Egg definitely came first. Yeah.
Because there was things laying eggs in the water.
Oh, this was it. This was it. This is this guy.
Hmm.
Dave Blunts, dude. This guy tries to say like 9 words and then almost passes out or something. Breathing very heavily.
I have no words.
I just be laughing my way to the bank.
Use your a little bit.
This man is struggling for his life, dude. Christ. Anyways, yeah, go. Actually, okay. So here's a good question, Sensation. You probably don't want to be 17 stones. What are you doing to work towards not being 17 stones?
It's complicated.
It is complicated. I know it always is.
I should become more ambulatory, but I get out of bed and sit at my desk. That's it.
Okay. Have you thought of maybe getting like a standing desk, or like a treadmill thing?
Oh, my body's way too fucked up. I mean, my lumbar can't take the pressure.
Oh, okay. What about like one of those things where you just pedal? I'll show you what I'm talking about. Just for anybody else here who's like trying to get more movement. It's like what was it? Desk. What is this thing called? Like a pedal exerciser. Here we go. Yeah, one of these, dog. Look at this. You could get this, right? You just sit down and you start pedaling.
Oh, don't.
Oh, well, why don't you?
In an unknown place at an unknown time. I'm not going to tell you any details. One of these things was hooked up to a what do you call dynamo, and we had to power the lights for a certain place at a certain time.
Oh, okay. This is his
which was fun because there was like 40 of us doing it.
This is his OSS days. You won't tell us about his MI6 days.
OSS. yeah. OSS. I'm like, I was born in 1920.
What's up, Zach's on the street?
Let's go.
What's up, Zach? Yeah, dude. Shout out to either 2I. He was running his linear algebra class today. Super cool. I stopped by it for a bit. Yeah, if you guys want to learn linear algebra, please, go follow either 2I Pi. Zach, he's a really good friend of ours, and he's running a linear algebra course. I think Tuesdays and Thursdays. Again, we posted the link for the calendar. You should go check it out. You can pedal power your PC? I don't think so. Those things don't really generate. This is actually a good physics question with like how much electricity these things generate. I think you could probably do a couple watts, if that. Let me see. Lots of curly fries and yeah. Let's see. Let's see what. I'm trying to think how many watts. There should be one of these things that generates power. Let me see. How many watts can a human generate on a bike? Let's say a bike, for instance. Let's say you're going all out at a bike. Okay. So an average person can generate 100 watts of power. Okay. 100 watts is not bad. At 12 volts, that's around 8 amps. And I mean, that's assuming 100% efficiency, right? No, sorry. Not 8 amps. What am I talking about? It is 0.8 amps. Oh, that's not very good at all. You can't even generate an amp as a human?
There's probably a correlation between how many amps it takes to kill a person and they can produce it.
Yeah. Well, you actually only need a couple milliamps across the heart to stop it. Yeah, an elite athlete can do 440 watts in short bursts. A healthy person can do around 50 to 100 watts. So your average computer probably takes at least, I would say, 400, 500 watts to run. Yeah. A laptop, maybe. A laptop, you could probably do 100 watts. You could probably power your laptop with a bike. I agree with that. Yeah.
If it's really shit, because you have to power the battery as well.
Well, yeah, I'm saying just to keep it, just to keep the battery at normal. You're basically charging the battery enough while it's discharging. Yeah, you could do it. But I think that's like a full-on bicycle. I think like a cute little pedal thing. Yeah, would probably be a little bit more. Anyways, yeah, I agree. Movement's more important. Also, eating things. You know, maybe planning out meals is a really good way to start getting yourself back on a nice trajectory. Eating at normal times. I'm a huge guilty person of this. I don't eat at normal times. I really should. But
I may have mentioned that. I basically don't eat. And that's where the problem starts.
Yeah. Some people think if like, oh, if I just eat one meal a day, I'll be fine. But if your body doesn't know what to do, it just stores it all as fat right away, right?
Yeah, but I take it to the extreme. It's like I'll wake up and I'll not eat, and then I'll have not eaten for such a massive period of time that I feel nauseous. And it's like, right, I need to eat something right now. And what can you eat when you're feeling nauseous? Well, you can't cook anything, so it's whatever's in a packet.
Yeah.
So you would benefit, all empty calories.
It's all garbage. It's like ramen and stuff. Yeah. So you would benefit sensation from maybe some meal prep. Yeah.
Have you seen my kitchen? Well, no. But
no, I haven't seen your kitchen.
It's probably not much bigger than 2 of these desks, to be quite frank.
Yeah. It's also a thing as we get older. You know, you kids, you students probably don't have to worry that much about weight loss because your metabolism is super, super high. You just have to go outside and walk around and get some steps in, which that is one of the things we encourage in our Discord. If you ever, for those that haven't joined our Discord yet, we have a challenge here called the Physical Education Challenge, and students will post, you know, the different amount of steps they got. If they do at least 7,000 steps 4 times in a week, you get coins. And then when you get enough of those coins, I buy you gift cards. So it's a win-win situation. You get better health and you get gift cards. Well, it's a win-win situation for you. I get the win of the satisfaction of helping you improve your life, but the dissatisfaction of my wallet. Oh, happy 1414 followers. Thank you, man. Yeah, congrats to Penn Center. He hit 1,800 today, I think, right? Or 800, sorry. 800, sorry. Yeah. What are you at now, Zach? You at 500? We'll start math questions here in a second. I like to just catch up with everyone from the weekend. What is Zach at? Zach is at happy 627 followers to you, Zach. Wow, 145 views. You had a lot of people on this, on your number 31. These are big, dude. 117. I don't even think I get that. I don't even think I get that many views. What do I get on mine? It's gonna try to pull me up. What do I get? It's gonna try to quiet myself. Yeah, look, 50, 60. Yeah, some of them are up there, but yeah, great job, dude. Good job, Zach. No sense in comparing. Yeah, no. I'm just congratulating you. I'm I agree. You shouldn't compare yourself to others, but I'm celebrating you in comparison. Okay. Should we start? Should we do some math questions? Shandrick says, I walk that much, but I don't have something to track it. Do you have a phone? Your phone will automatically track everywhere you go. Mark Zuckerberg already knows, like, you know, where you go to bed. You have a laptop. Yeah, okay. Another option, and I always say this for the students who say, you know, I don't have a phone or I can't track my steps. If you live in the U.S. and you want one of your prizes to be one of these things, I'll buy it for you. But it's a pedometer. I know, super old school, right? But yeah, look, this thing is $16. Please let me buy this for you. But it's just a device that just uses an accelerometer, I think, to track how much you go up and down, and it'll basically count. This is $10, dude. $10. And it'll track the number of steps you have. So
we were given these at school.
Yeah, we were given these in school too. When I was young. Yeah, because we didn't have phones. Nowadays, everyone has a phone, so it's fine. Dr. 79, Dr. 1. Yes, I am. He's referring to 79 as the atomic number for AU for gold. E the 2i pi. You're supposed to be Dr. 1 now. I would like to enter into a weight loss competition. Those are cool. Yeah, they have these at work a lot. My sister has, she's a nurse, and they have weight loss competitions amongst the nurses. It's good to just have like I call it like an accountability buddy. It's just good to have someone else doing the thing with you, because then you keep each other accountable. Yeah. I don't know. Sensation, do you have any other like friends in the town that would also benefit from losing a stone or two?
No, they could all benefit from putting on weight, to be honest with you.
Oh, okay. Well, maybe you can donate some of yours to them.
It's the middle of nowhere.
I know. Yeah. Well, in that case, we have the internet, right? We have tons of people on the internet. Yeah.
Funny thing is, I'm not actually supposed to lose that much weight. I'm
okay.
Objectively speaking, I'm probably 2 stone overweight.
Then yeah, that's not bad.
In fat. So.
Oh yeah, you got a lot of muscle. No, I agree. Like stuff like BMI stuff is terrible for actually, and they're overhauling that in the U.S. They're getting rid of that as a thing. But okay, here let's do some. Go on, Sensation. You're good. What were you gonna say?
I was going to say I've still got a reasonable muscular structure. It's just there's a lot of visceral fat over the top of it.
A lot of padding. Yeah. Well, I say abs are made in the kitchen. You just got to fix the diet, and then just move around a little bit more. And you'll be fine.
They're still there because I can still move them independently. I can still move all of my primary muscle groups independently.
Good. Yeah. If you still have the muscle, then if you have the muscle, you're good. The problem is with, like, when people get so overweight that their knees can't support the weight anymore, then they can't exercise. And
it's not my knees that can't take the weight.
It's what, the ligaments?
It's my L1 through L4 that can't take the weight.
Oh, your lumbar. Yeah, okay, your spine. Well, yeah. This is where the sit down pedal thing would help. Yeah. Let's do it. Let's do a Sensation. Come on, dude. Let's get you the pedal thing. So you're just like pedaling.
Buy a bike.
Yeah, buy a bike. Not a bike, just like one of those like it's underneath your desk and it just pedals. Okay, I'll get here. Let's start office hours off. Let's help some kids with math and science and start with Scream. Welcome everyone, office hours. My name is Dr. Gold Sex Education. Scream to help you with math and science homework. All sorts of fun stuff. Shantrix has the first question today. He says it's the last question, so it might be difficult. Yeah, I agree. Yeah, number 25 of these Pascal challenges is always pretty tricky. Okay. But it says, all right, a regular prism PQRSWTUV. I'm glad someone knows how to spell out the letters in the alphabet. Has a base PQRS. Point X is on the face of TUVW, such that PX. Okay, so there. Okay, here. Let's do this. Let's do it real quick. So there's some point here, X, such that PX is equal to 12. QX is equal to 10. Oh, okay. Am I going to use vectors for this? I feel like I want to use vectors for this. And RX is equal to 8. Oh.
If I'm right, you don't, because I've seen this before at higher GCSE level.
Yeah, it's not that hard.
You don't use vectors. I don't have the book to hand, but I have seen this before. So it's
Shantrick says to use grade 10 math in this because apparently it's Okay, so I'm not going to use vectors then because vectors is not grade 10 math.
Grade 12.
PQUT. Wait, what? The maximum possible. Okay, so they want the maximum possible area of this. Is closest to one of these. Wow, look at the dude. What fuckers, dude? 67.84, 67.82. The difference is 0.02. That's a rounding error, dog. How are you supposed to get that? Oh man, all of these are super close. Okay. Okay. Oh, well, at least we know it has a square base. PQRS. Okay, so at least we know, right? I know that this is equal to this. Like, this must be a square. Okay, so if it's a square, then that means this thing here must be whatever this is, like square root of 2. Or square root of 2 over 2. Right? If this is 1, this is 1. No, sorry, this is square root of 2. Square root of 2 times it. That's what I meant to say. Okay. Ugh. P, Q, R. PX is that. QX is that. RX is that. Dun, 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 dun. Okay. I don't have to use vectors, but I think I can come up with like what a coordinate for this thing is, right? Messi says, "Do I need the music class?" Maybe submit yourself playing a piece of music. That would probably be the only thing. Yeah, the whole point of the music class challenge is for you to show that you're practicing an instrument, not just pressing random keys. Yes, I saw you submitted one. Yeah, I don't care about the metronome or the background music. I want you to actually play a piece of music. I had some kid who was just like fucking like hitting the keys randomly, and I was like, okay, dog. But yeah. Okay, let's think. Because I mean, this is gonna form some sort of triangle. So 12 is going to be the hypotenuse of a couple things, right? I believe 12 is going to be the square root of this distance, and this distance. Interesting. Okay. Right? Something's going to have to go this much this way, this much this way, and then this much this way. And so this distance, 12. So this is like a percentage of PQ. Here, I'm going to assign some variables to things. Let me call this just A, okay? And then I'm going to call this thing here B. And what I know, right, is that this side of the box is the same as this side. So this is also A. Yeah, I mean, you can have background music, but I mean, try to play as much as you can originally. All right. Okay, so it's always going up a height B. Okay, that's always this, and then there's some percentage of A that it goes this way, and then some percentage of A that it goes this way. Okay. So let's assign some variables. Because, okay, and what I'm trying to maximize is this. So I'm trying to maximize the area of this rectangle, which is B times A, right? The area of a rectangle is the base times the height. So I'm trying to maximize A times B. So let's come up with some conditions for things. I'm going to call this, I'm going to call this X. I'm going to call this Y. So where X is, I'm going to say the percentage of A. So this is XA, YA. Right? And then I think I know what I want to do here. Yeah, okay. So then XA squared plus YA squared plus B squared must be equal to 144, right? Because that's this squared plus this squared plus this squared must equal this squared. It's like an extended Pythagorean theorem in 3 dimensions. And then how do we get to this distance? So that's going I think I see it. Okay. From here, going in this axis, that's going to be 1 minus x in this direction. So if you go x% this way, you go 100% minus x% in this way in order to get from here to here. Does that make sense, Shantrix? Yeah? So I would say this is 1 minus x a little bit. You know, fuck the x and a stuff. Here, let's have x be the distance. I'm just going to have x be the distance, and then we'll try to figure this out. Okay. X squared. I'm going to measure everything from here. Okay. So this measures x. This measures y. And then z is measured from here as well. Okay. So x squared plus y squared plus b squared is equal to 144. From here, right, the distance this thing goes is going to be a minus x squared. The distance in y is still just y. And then plus b squared is going to be equal to 100. Okay, cool. Okay, now going from here to here, okay. Now there is no well, no. Sorry. It's still a minus x squared. And now for the amount of this distance, it's a minus y squared plus b squared is equal to 64. Does that make sense, anyone, so far? Like how this is working? It does? Okay. Let me explain how it would work in 2 dimensions. It's a little tricky showing how it's working in 3 dimensions. Let's say we had this. Let's say I had a square. Okay. And I'm going to call this distance here x. And I'm going to call, so this distance, well, here, sorry. We're going to call these side lengths a. And then we're going to define a point that is right here. That is located x away from here. And then is located, this is a top-down view. This is just, if I was doing it just in 2 dimensions, okay? So then this distance, let's say this is our distance. Let's call this, I don't know, like distance d1, right? d1 would be equal, d1 square, here, this is a right triangle, right? This and this. So I would say x squared plus y squared is equal to d1 squared. d1 athlete, yeah, okay, cool. All right, that's measuring it from here. Now let's say instead I measure it from here, okay? We'll say this is another distance d2, okay? This forms a triangle where this distance is still y, but now this distance here is a minus x. So I would say a minus x squared plus y squared is equal to d2 squared. And then if I wanted to measure it from another point, let's say I measured it from, I'm running out of colors. We'll use gold. Okay. Let's say I'm measuring it from here. Let's say this is d3, okay? Now this distance, right, is a minus the y. This is a minus y. This distance here, again, is x subtracted from a. So then this is a minus x. And so you would get a minus x squared plus a minus y squared is equal to d3 squared. This is how to do it in 2 dimensions. If you add a 3rd dimension, such that this is coming in and out of the page, all you have to do is add that z coordinate over here. So this would just be like plus z squared. Yeah, add the height. Exactly, yeah. So that's what we're doing here. So from here, that's just this straight thing, right? A squared, or sorry, x squared, wherever it is in x, wherever it is in y, height. This one right here is equivalent to the d2. So the x coordinate is now a minus x, blah, 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 blah. And then this one right here corresponds to this one. Now we have a minus x, a minus y. Okay. The cool thing about this is I'm just trying to maximize a times b. So I'm solving for a times b. And here I have I have 3 equations with 4 unknowns. X is unknown, Y is unknown, A is unknown, and B is unknown. 4 things that I don't know. And I only have 3 equations, which means I can't solve for everything. But I can probably solve for a combination of the things. Let's see what happens as I foil these out. I'm really curious, actually. Something cool is going to happen here. I guarantee it will. So this one is going to stay as is, right? X squared plus Y squared plus B squared equals 144. This one is a perfect square binomial. Oh, you know what the beeping is from? It's from the lo-fi music. This lo-fi music for some reason has a fucking microwave in it. Oh man. Okay. This is a squared minus 2ax plus x squared, and then right, it's plus y squared plus b squared equals 100. This one is going to be a squared minus 2ax plus x squared plus a squared minus 2ay plus y squared plus b squared is equal to 64. Okay, so all I did was expand this out to this, and then I expanded this one out to this. Y'all should always know this, right? A plus b squared is equal to a squared plus 2ab plus b squared. And if this is minus, then this is minus. This is, again, I know these challenge questions kind of look like, you know, what the fuck? They seem just really hard and tricky, but you use a lot of skills that you're supposed to know from earlier math classes, such as, yeah, this the expansion of a binomial. Okay. So, what do I see cancels here, maybe? Oh, I see something right off the bat. This is really cool, actually. So, do you see how this x squared plus y squared plus b squared? That's the same thing here, right? So, that tells me right away that I can replace this whole thing here with just 144. It's really nice, actually, right? Okay. So, let's try to do that. Let's substitute all this in for this. So now I have a squared minus 2ax plus 144 is equal to 100. Okay. All right. Or I can say that a squared minus 2ax is equal to negative 44. Right? Okay. I think this is going to come in handy because I see an a squared minus 2ax here. I'm probably going to replace as well. And then I have x squared plus y squared plus b squared is equal to 100. Which... Let me make sure it's just not going to No, that's okay. Yeah, okay, so let's do that. All right, so now let me substitute this into this. It looks pretty cool, right? Yeah, let's just substitute that in. So we're going to say negative 44. And then I have x squared, y squared, b squared. We all know that's equal to 144. So then I'm going to say plus 144. And then this last part, right? Plus a squared minus 2ay is all equal to 64. So, negative 140, this goes to 100. And then I can move that over. And now I get that a squared minus 2ay is equal to negative 36. Oh, boy. Right? I think we're okay so far. We are definitely getting closer. At the end of the day, I'm trying to maximize a times b. And when they say to maximize, it's usually because this function is going to be some sort of parabola. Well, I hope it's this type of parabola. Because the maximum will end up being the vertex. So just know that in the back of your head. When you're trying to solve this, we're trying to get A times B to be something with, like, squares in them. Now, I fucked up here. Because there should have been a B somewhere. Why is there not a B anywhere? I guess not. Okay. Yeah, okay. So now I have these two. I have these two equations. Can we do something with these? I want to say, like, I subtract them, and that gets rid of a squared. And then... Oh, man. We're close. We are so close. There's a trick somewhere that I don't see. I can write, so from this, I can write b squared as equal to 144. Or I could say 144 minus b squared is equal to x squared plus y squared. I think ideally that's what I want. I want to replace x squared plus y squared with this, and then just have something with a left in it, and then something should cancel. Because I see y, I see x. I want to get rid of x and y, though, because x and y... What does it says? Yeah, because we just want to maximize the area, so I don't really care where the thing is. I want to get rid of x and y. Okay, I think I see this. Let's try subtracting this one from this one. Let's do... I think I see where this is going. Let's subtract this from this. Let me show you why. Because when I do that, right, this goes away. And then I have negative minus this is positive. So I have negative 2ax plus 2ay is negative 44 plus 36. So that's equal to negative 8. So let's run everything through by negative 1 just because I want to make things happy. Oh, also I can divide by 2, right? Divide everything by... Let's just divide everything by negative 2. Okay, cool. So I have ax minus... Okay, so a... x minus y is equal to negative 4. Damn, but I want x squared plus y squared.
Right, I have no idea what the crack is, but go back to the original image.
What's that, the original image right here? What do you got,
right.
Sensation?
Just out of curiosity, if you've got
Yeah,
QX and if you've got PX and QX,
yes.
Can you get PQ?
Can you? Oh, good question. I think the issue is that PQ could change depending on where X is. So let's say
but it has to be in one place though, because it has a distance.
It has a distance of 12 and 10. I agree, but the position would change, Sensation, based on how wide this was. If this was like very narrow, then I would need this to be much further down the thing. You are probably right though, because this has to be a square, so there is a restriction on that as well.
Well, the restriction has to be that if you have a triangle there, one's
Yes.
12 and one's 10, then
But it's a
the
3D
other
triangle.
side of the other side of the triangle, huh?
The
Well,
issue is it's a 3D triangle. It's not a
from
nice
from one perspective.
Sure.
It's still a triangle that has one length and another length, so it must have a third length, which must
Correct.
be static.
Well, it depends on the angle. Because again, this could
Right,
be
yeah.
12, and then this could be wide out here and something. Yeah, two sides don't define a triangle, unfortunately. You need two sides and an angle. And even then, yeah, no, two sides and an
Mechanically,
angle.
it's equilateral.
Yeah, well, you do know that this base is the same as this base, so maybe that helps. Because then I know that
It's just if the play is area, then you work out the area of one face of the triangle, and then
yeah, unfortunately,
extrapolate between T, U, and X, and then you end up with the entire face.
correct. Yeah, if I could get X, but then I'd also need to get B. That's essentially what we're doing here. When we're creating these formulas right here, we're creating kind of like mini triangles and stuff. Messi says, I think you need 12 squared. What? 12 squared, 12 squared, 8 squared. Under rot, under rotation, and that's it. What? I don't know what that means. Dang. Well, I got X minus Y, damn it. Doesn't really help me though. Fuck.
But yeah, no more of these. After
They're
this,
good.
There's just
There's
no point. It takes 4 hours to do.
No, it's okay. I always say I give up after like 15, 20 minutes just to make time for kids, but I do appreciate these. I used to hate these. You're so right, Sensation. I was thinking about banning these questions, but I like them now because they teach a way of thinking, which I think is important. The fact that I got this far is much further than I would have gotten a couple weeks ago when I was severely distraught over these questions. But now, because I've done enough of them, I start to see that there's a pattern. I know, I know, Shantrix. I can always explain the solution. I'm just, because that's the other good thing, is that when Shantrix gives us these questions, they already have solutions published, which I love, because then I can go through and see what they did. I just, for my own sake, I want to try to get it by myself. But sometimes it doesn't work.
Yeah, definitely need more students bringing in the answers as well.
Yes. Yeah, fuck. Man, I'm so close. This is cool. I have this. And I just need A times B. There's some other restriction I'm missing. There has to be. Alright, let me just give me a little bit more time on this. I think I got this. X squared, Y squared, B squared is 144. Cool. So that gave us A squared minus 2AX plus 144 is equal to 100. Cool. Okay. And then I have A squared minus 2AX. All right. So that's all 100. Yeah. Okay. Because this part here is all the same thing. And that equals 64 minus that 36. Okay. Sometimes it's like it's a division thing. Maybe this is a division thing. Okay. What if... Yeah, what if I divide this one by this one? Let's just see. I'm just curious. So this is A. A minus 2x is equal to negative 44. And then this is A. A minus 2y is equal to negative 36. If I divide these two by each other, A goes away. So I get A minus 2x over A minus 2y is equal to 44 over 36. So divide by 4, it's 11 over 9, right? I kind of like this a little bit better. Messi says, and that's a 67.82, bro. Where are you getting that from? Yeah, what's the under rot and that is IDN? Yeah, I don't know that part. 1 sec. 11a minus 22y is equal to 9a minus 18x. This is going to get me the same thing. Well, maybe it does. Wait. I subtract that. 2a minus 22y plus 18x is equal to 0? Oh, interesting. Wait a minute. Am I doing something wrong here? Negative 2ax plus 2ay. Negative 8. A x minus y is equal. Okay, first of all, not equal to. Yeah. Wait, whoa. Equal to 4, not negative 4. That was a mistake. Okay, and then if we divided these two, I think what I said is right. Okay. Yeah, 9a minus 18x, 11a minus 22y, subtract 2a, or we could say this, and then I think we can divide by 2. So a minus 11y plus 9x equals 0. Okay. 9x minus 11y equals negative 9. I need another equation. And unfortunately, these aren't the same. What's up, Dennis?
My man.
Yeah, you're good. Yeah, good. Class has just been starting. Yeah, we're doing a little challenge question here. What am I solving? Yeah, this is what I'm solving. This is the question. Shantrix, send me the answer. Send me the answer, Shantrix. I'm close. Thank you. All right. Here's the answer, Here's the answer, guys. We're gonna post it. All right. Let me see how many pages this solution is. Okay. Ooh, look. See? I had the right method. See how they do here? A minus m, a minus n, and then they're. Sorry, what? Yep. And then they're calling whatever. This is some distance. Okay. Well, this is a little bit too much. Mm-hmm. Yeah, see the 100? Yeah, here we go. Okay. Okay, I think I was close then. They say solve for x and then solve for y. Is basically what they say. Oh. Oh, I'm stupid. One sec. Yeah, okay. So they use this equation to solve for... They use this to solve for x, and they use this to solve for y. I was trying to get it to cancel nicely. It didn't, actually, unfortunately. So... Okay. So if I rearrange that, I get a squared plus 44... over okay, equals x, right? Is that correct? No, over x. Over 2a equals x. Okay. And then from this one, I get a squared plus 36 over 2a is equal to y. And then they're plugging this and this into x and into y, I believe. Which is what happens here. And then we want to maximize a times h. Since a times h is greater than 0, then maximizing ah is the same thing as maximizing a squared h squared, was equivalent to maximizing 4a squared h. Why are they doing that? Oh, that's clever. Because the 4a squared is going to cancel out all the denominators. Wow. Okay. Yeah, Shantrix, this is the part I wouldn't... This is the part I wouldn't have gotten this. This is a cool solution, though. Yeah. I thought, yeah, we have to maximize a times h, so I was trying to get this to look like a times h. They go on a tangent here, being like, well, a times h is an area, has to be positive. So if you maximize a times h, it's the same thing as maximizing that thing squared. And then if you're trying to maximize this thing squared, it's the same thing as trying to maximize 4 times it squared. So if I multiply this by 4a squared, I multiply this by 4a squared, I get rid of all these denominators. And now I just get this expression, right? Which is a quadratic. And then you have to find the vertex of this, basically. Yep, they put this in. This is in vertex form, right? And so the vertex form of this is when a is the square root of 104. So, oh man, that, yeah, oh, wow. Okay, cool, whatever. I get it. It's completing the square. Yes, okay. This is another very good point, because people yell at me on my TikToks when I say, here's how to complete the square for quadratics. And they're like, well, you could just use the quadratic formula. No. No. I mean, yes. I mean, you can use it to solve quadratics, but as we see in this problem, knowing how to complete the square is very important to be able to do this. Yeah, this is cool. Okay. So, regardless, we were on the right track for this question, and I'm at least proud of myself for having the right train of thought to start this. But the little piece I was missing is that when you plug all this back into here, you just try to get it, instead of trying to maximize a times b, you maximize 4a times b squared. Because, yeah, oh, this is so cool. Because, yeah, if I plug each one of these in, right, now I get 144 is equal to, that's a squared plus 44 squared. All over 4a squared plus a squared plus 36 squared over 4a squared plus b squared, right? Or no. Here we go. We can leave the minus there, right? Is negative b squared. Messi says I'm right. Well,
no.
I don't think Messi is right. Messi just wrote down random numbers.
It doesn't say I'm right. It says I'm right.
He forgot that. Oh yeah, watch out! Sensation's gonna come after you, dude. Yeah.
If English isn't your if English isn't your first language, that's probably reason enough to use it properly.
Oh my god. Yes, because then if I multiplied both sides here by negative 4a squared, I multiplied this by minus 4a squared, right? This goes away. Then the nice thing here is that this will cancel with this. Makes this positive, makes this negative, I guess. This goes away. And then you have something just strictly in terms of a, which is nice. And then this is kind of like, I guess, the y you're trying to maximize. And then if you figure out what that's supposed to be. Oh, so actually this, well, okay, that's gonna cancel a bunch of things. And then you just gotta divide it by 4 and then square root it. Very cool. All right, whatever. That was a cool question. Thank you for that one, Shantrix. I appreciate it. Cool question.
And don't worry, Missy. I'm here for you.
Yeah, he's here.
Well done.
Sereno says, completing the square is fundamental. Thanks to that, Italians were taking nice jobs in academia by dueling other mathematicians. Oh, pray tell, dude. What? Dude, what? What's this with Italians dueling each other over completing the square?
Actually, that's interesting. It doesn't say Italians were dueling each other. It says Italians were dueling everybody else based on that.
Oh.
Were they just going to the US and just challenging mathematicians?
Just like, I challenge you to a duel.
Some of my trap card.
My trap card.
I've forgotten everything about that show.
It's such a different meaning now. What's up? Ace, are you here? You want we'll do your question about looks like native Canadians using to boil water from maple tree sap. Oh, they're explaining how you make syrup. I love syrup. Syrup's dope.
That's dope.
Love syrup. Yo, what's up, dude? All right, cool. Let's do it. All right, native
Am I
Canadians.
stupid and just assume it comes out of trees.
No. It comes out as like watery liquid, and then they have to boil it down. It's basically a reduction. Have you done some cooking before, Sensation? A reduction?
Probably.
Have you made simple syrup before?
No.
Okay. So if you take like a bunch of sugar and you put it into water and then you boil it, you get rid of the liquid.
Yeah.
Pardon?
You make caramel.
Yeah, you make caramel. Yeah, basically. Yeah, I mean, that's what syrup is. Syrup is basically caramel. But it's from trees.
So yeah, I just assumed you like tapped a tree, put a thing in it. What's it called?
A hose.
There's a word for
or a spigot.
Yeah, that's the one. You put a spigot in a tree, and I just assumed it comes out.
Yeah. So when I used to live in Vermont, they would put buckets literally on the tree. So one sec. We're taking a little detour into maple syrup land. Maple syrup buckets. So they would literally do this. They would put a hole in the tree, put a little spigot, and they would put a bucket, and then these buckets would collect syrup. Now what they do is they have fucking hoses.
Wow.
So now they have a bunch of vacuum lines running around all these trees, and now they're just sucking all the sap out of the. So now someone doesn't have to go in between all the trees and collect the buckets. They just go and just get all the syrup. Poor trees, getting sucked off every day. Anyways,
I'm ready.
Nice.
Anyways, here let's do this question. Okay, native Canadians used to boil water from maple trees by heating rocks and placing them into vats of sap. Oh, sitting in hollowed out tree logs. Assume this. Okay, there's a lot going on here, honestly. Heating rocks, vats of sap, sitting in hollowed out tree logs. Assume that the syrup and the rocks have heat capacities of water and sand, respectively. Okay, so I have to go look some things up. So yeah, the syrup. So the heat capacity of water, I believe, is 4.186. I don't know what it is for sand. And then for sand, yeah, can you tell me the heat capacity for sand? Or it's 4.184. Thanks, Jeff. I always get that wrong. Oh, because it's in kilograms? Sure. You're right. Okay, 40. It's 4.184 kilojoules is what it is. Yeah, you either do the kilograms or the kilojoules. Sorry. Wait, who keeps messing with me? Is it 4.184 or 4.186? It is 4.186. Jeff, are you messing with me?
No.
Jeff. Yeah, Femvox. Yeah, isn't it cool? Yeah. I posted the solutions in the chat. It ended up being once you got to this point, you write X and Y in terms of A, and then you plug it back into your original thing, and then you manipulate it to look like something that you can just optimize. It's pretty cool. Wait. Jeff says it's 4.184. Okay, one second. It is 4. Okay, we have two conflicting answers here. AI says 4.184. The Department of Education in Canada says it's 4.186.
Rounding error?
Well, it depends on the temperature, I guess, of water. Wikipedia says 4.184. Interesting. Where's the 1.8? Oh, so is your teacher wrong? Because this is saying 4. We're arguing about 0.002. Yeah. Okay, whatever. All right, I'm gonna use 4186. Okay. The formula sheet was given as that. We'll use what the formula sheet's given. Okay, and then this has a specific equal to 800. One sec. Why is the AI music like so low? I don't know. I just made it like super low. Okay, monster. Yes. What massive stone heated to 100 degrees Celsius would be needed to increase 20 kilograms of sap from 60 to 85? Okay, very cool. Let's say the answer is 2.87. So let's go look at it. All right. So how this works is that Q lost, so the heat lost, has to be equal to the Q gained. So sometimes we put like a negative sign here. I think it's kind of this, right? Isn't it Qn equals negative Q out? And then Q is MC delta T is equal to negative MC delta T. All that negative ends up doing is switching the order of this. So delta T is always the change in temperature, which is T final minus T initial. And so the negative here, we should always remember that if I have like A minus B, if I wanted to flip them, that's the same thing as negative B minus A. So a negative coming inside switches the order. So that makes this one equal to like Ti minus Tf instead. Anyways. Okay, so we have some mass of stone. We're just going to say M. The specific heat of the stone is 800. The change in temperature, so that's going to be some final temperature. Well, okay. We're assuming that the stone and the liquid come to equilibrium, which means they end up at the same temperature, which is 85. So this is going to be 85 minus 1,000. And then this is going to be equal to negative, but I'm just gonna get rid of the negative, changing this from Ti minus Tf. So that's 20 kilograms. Specific heat there is 4186. And then this is Ti, which is 60 minus 85. Exactly. Yeah, we do need the heat gain by the sap. Yeah. Okay. So this is it. And all I'm doing is just solving for M in this case. Usually the more annoying version of this question is they make you solve for what the final temperature would be. And algebraically, it just becomes more of a mess. Because then you have a variable in each one, but one's being subtracted and the other one's in the front. It's just annoying is what it is. Yeah, right? Yeah, it's super annoying. This is nice. because I'm literally just gonna I can just calculate this at this point, right? Because if I just take this stuff and move it over, super simple. Right, we just take this underneath here. Now we're done. Oh yeah, the question I got on my final performance talks was much worse than Lost. What? Oh no.
Oh no.
What do you mean it was much worse? Dude, his Lost questions were terrible, dog. What? Excuse me? How is it much worse? How can it be much worse? Yeah. This is the heat. This is the heat lost by the stone. And this is the heat gained by the sap. Messy. So if I do this, this is what? 20 times 4186 times negative 25 divided by 800 times negative 15. Not minus. What am I doing here? 800 times negative 15. Oh, not negative 15. Excuse me. Sorry, 85 minus 1,000 is not negative 15. Nope.
Disqualified.
It's negative 915. My bad. 85 minus 100 is negative 15. Yeah, there you go. Okay, that gets us 2.8859 kilograms. So we get 2.86 kilograms. Close enough. But nice. Good job. The first part, the male teacher made it, and it was doable. The second part, the female teacher made it, and she was hardcore. That's unfortunate. I'm getting more contest questions. Equity posted a Kaylee question as well. You guys love these contest questions. They're fun. Okay. Let's see. Reiki Rex got a stats question. I got the 4.186. Messy. That's what I got. Wasn't too bad. Z-scores. These are very important. I like these. Has to do with statistics. Sec. What's up, Reiki Rack? Okay, cool. He's here. All right, nice. Good. All right, cool. We got some like slow jazz, dude. The TI-84 actually does solve these. Let me show you two ways to do it, actually. So, if you got, for instance, a table. Yeah. I'll show you how the TI-84 does it. But here's like a Z-score table. These are very cool, actually. I think we want it in this left tail, though. That's what we want. Let's do this. Yeah, there is an inverse function. I'm pretty sure there is. There we go. Tables, yeah. Have you guys ever seen like a random number table? Have you guys used those before? You use them actually in stats classes. You guys ever seen these before? It's just like it's a series of numbers that are just random. This is the old school way to generate random numbers. And I think, right, if you wanted a 3-digit random number, it's like 365 183 677. Wait, I can find a pattern. Yeah, I doubt it. Final temp, we got 2.86. That's what we got. Kilograms. Messy. Yeah, just give me 20 years. Okay. So the z-score, if something is any finite sequence of numbers has a pattern. You mean like it's just the whole, this is just the whole series of numbers? I mean, yes. Polynomial fit. Any sequence of numbers has a pattern? I didn't know that. I mean, if it were to repeat that self again, I guess, right? Are you talking about, like, for instance, if I had like 1, 3, 6, 5, that would repeat again 1, 3, 6, 5 because it's this finite number? Yeah, if I know when it ends. How are you going to complete the square here if you didn't even start the square? Yeah, no completing the square here. This is stats. There's no completing the square can't hurt us here. Okay. 33% of the data is to the left. So here, this is a table that shows the area to the left of a certain z-score. Oh, the final temperature? Or they told us what the final temperature is. They said it went from 60 degrees to 85 degrees. Yeah. Yeah. Okay. So, these show the area, and what we're looking for is something close to 33%, right? We want 33% of the area to be the left. So you just look in the table here for where 33% is most likely. And that looks like right around here. Oh, actually, it's exactly this. That's actually really cool. Okay, so it's this. So we're trying to look for this area right here. Do you know how to read this table, Reki? Like, if this is the number I'm looking for, what z-score does that correspond to? If I know it's right, it's this row and it's this column. It's good to know how to read these. What ends up happening is, so whatever the row is, so whatever one of these it is, that gets you to the 1 decimal place. Okay. So for instance, everything in this row is negative 0.4 something. We don't know what the next decimal is. The way to figure out what the next decimal is to see which column it corresponds to. So since the one we're looking for, Reki, right here, which is 0.33, is in this column, that corresponds to the next decimal place being 4. It says 0.04. So, yeah. So this ends up being negative 0.44. Yeah, good job, Missy. Yeah, good job, Missy. Yeah. Okay, cool. So that's equal to negative 0.44. All right. Now it wants to know where 20% of the data is to the right of the z-score. Yes, that is the mass. Yeah, good job. Good job, Missy. So we want this amount to be 20%. So it's actually cool. So z-tables are symmetric, which means if this entry, which in this case, right, was negative 0.44, gave me 30% of the data being here, positive 0.44 gives me 33% of the data being here to the right. Right. So if I want to figure out where 20% of the data is to the right, I need to, again, use my table here to try to find out where 20% is. But that z-score, I'm going to flip the sign of it and make it positive. So, yeah, let's see. Where's 20%? 20% looks like it's right around here. It's in between these two. So, let's do this one. This one looks closer, right? And, oh, nice. It's the same column. So that's just going to be, that would be negative 0.84, right? You see how we have the 0.8 and the 0.04? 0.8 plus 0.04, that's 0.84. And then this is negative because it's areas to the left, but we want the amount to the right, so you flip the z-score sign. So this is just equal to 0.84. Okay. The other way to do this, again, is you could use your calculator, which I think it's is it here? It's under stat. Yeah. Well, yeah. These tables won't ever show like 80%. Actually, this one would actually. Sorry, what was it? Yeah, this one, right. If you wanted to use this table, you're correct. 20% to the right would mean that 80% were to the left. And so you would look here for where 80% is. Which, right, yeah, right here. It's 0.8, 0.04. It's basically 0.84, yeah. Okay, but Femvox says it's dist inverse norm. Okay, let's do that. So second vars, which is dist. Oh, inverse norm. Very cool. Area. Okay, so we put the area we want. So we want the area to be 33%, right? Can I say just 0.33? Mean 0, standard deviation 1. Cool. Yeah, that gets us negative 0.4399. So basically 0.44. So that's nice. And then, okay, so this is always area to the left. So you're right. We would have to make this 80% to get the 20. And then there's the 0.84. Right. So that's the quick way to do it. If you have a calculator TI-84, you can literally use the buttons here to just look things up on Z-tables. Super useful. Or this is a valuable skill to have if they're still making you do it on the AP exam. When I took the AP exam, we had to use the tables. We weren't allowed to use the TI-84 for this stuff. But nice. Okay, good. Good question, Riker. Let's go.
Oh no.
Oh no.
Oh no.
I'm not even from down south.
Down south. Did you like my Scottish translation book thing?
I said that it's a mixture of Scots and Scots English. I think they sell it to tourists in Edinburgh.
Oh, do they? They sell this thing to Scots in Edinburgh?
It's because it's not quite right, and you would only it's half and half, and you would only know if you're a native.
Oh.
So
Femvox says
so,
he has video game envy of everything you have. Says he's envious of your video game collection.
Which all needs to go because I need the space to put another desk.
What are you gonna do with the other desk?
I need a proper desk.
Okay.
Right now I'm using 2 IKEA tables.
Oh, I see. You want to get like a proper like gaming desk or something.
No. I need like a proper office desk because I'm getting nothing done because everything's a bit
Messy.
the dimensions aren't quite right and you can't use it properly. It's a whole thing.
Oh, I see. Okay. But sorry, you were saying about the Scot thing.
Scotland has 4 languages: English, Scots English, which is distinct, Scots, which is something else entirely, and Gaelic.
And Gaelic. Yeah, this was the thing I saw at the. Oh, go away, Olaf. This was the thing I saw at this bar.
So
ugly is that Hackett, Gads. Hackett.
So some of this is English. Some of this is Scots English. Some of this is Scots.
What about Moni a Mickle Max a Muckle?
Money a Mickle Max a Muckle.
It's
okay,
like a penny saved is a penny earned.
This will crack me up for you to try and say this, right?
Yeah. Which one?
Glaikit.
Glackit? Gleekit?
No.
What is it?
You'll never get this.
Glaikit?
It's Glickit.
Glickit. Not very clever.
Glickit.
Glickit.
See what I mean? It's.
I love how. Oh, Femvox says their dad's favorite poet is Robert Burns. Is he a Scot? Robert Burns?
Yes.
Yeah. Oh, Geggy? Geggy is mouth?
Egypt.
Oh my god. Dineh?
Horchin. Dinny.
Dude, There's so many good ones here, man, dude. I want to. Can't be Erst. I know this one from you guys. Can't be bothered. Yeah. It's like can't be fucked. Sletcher?
Erst. Huh?
Sletcher? Messy or clumsy?
Slecher.
Slecher. Tattiest potato, dude. What?
You can.
Oh, man.
Tram. Scalp. Wabbit.
No, just hold on.
No, just hold on.
It sounds like, yeah, just hold on, dude. What?
Quite a lot of these are very Glaswegian rather than specific to Glasgow.
Oh, wow. I learned something today. Slacker does French, yeah, that's what he says.
Well, yeah, because there's a big history between Scotland and France. So.
Oh, is there?
Well, yeah, we basically fought against the English at all for like hundreds and hundreds of years.
Did you put a poll up today? What should Dr. Gold teach today? An entropy or inertia?
It's because I asked ChatGPT to give me 2 physics topics, and it just said entropy and inertia.
Yeah, those are some pretty good topics. I will agree with you on that. They are. Let me see who submitted our most recent question.
The Scottish people hate the English because they conquered us and killed half of us.
Scots
the French hate the English because
Brits. Yeah.
Scottish people hate the English because they killed most of us. French people hate the English because they did something similar to them.
I see. Oh, and what about the Irish? Where the Irish just hate everybody, right? Is that how that works?
The Irish are too busy fighting amongst themselves, but then so were we.
But I feel like the Irish are like fighting amongst themselves because part of themselves supports England, right?
No, the Irish fight amongst themselves because half of them are Protestant, half of them are Catholic.
That's it. The Catholic versus Protestant. Yeah, that's what it is. The Irish love the French. Ooh, okay. Didn't know that.
There was a story about that. We went to France when I was like 12 or something, and they thought we were English because you're driving because we all have the same number plates.
Sure.
And so it's like, no, we're Écosse, and they were like, oh, awesome. Their demeanor changed. Their demeanor changed immediately.
What does Écosse mean?
I think it means Scotland in French, but.
He says the Irish had a regiment during the Napoleonic French. Oh, in the French army. Oh, that's cool. During the Napoleonic Wars, I guess. Oh, here's their regiment, dude. Oh, let's check this out.
It says the French Foreign Legion of Ireland.
Yeah.
That's what that says. Regiment Étranger Légion d'Ireland. Yeah, it says the French Foreign Legion of Ireland.
Oh, that's cool. Yeah, they love the harp. They love that harp. Nice. Here, let's do Adarsh's question real quick. Then I'd love to learn more French, Irish history. What's up? Which one do you want help with, Adarsh? Which one? These are actually both pretty good. These are like SAT questions, I feel like. Okay, all right, fine. A sporting goods store added 50% profit cost and 8% tax to the price of a backpack, which then became $129.60. What was the price of the backpack before adding profit and tax? This is a really good question, actually. Yeah. Trying to figure out what the original value of something is. You're close, Shantrix. You're close. So I like to think about this as, let's say we have something that's originally costs X dollars, okay? And then I want to put a 50% tax on it, right? Yeah, I assume that the tax and the profit are applied to the original base price. Yeah, I agree. Does that make sense? Yeah, because the tax is collected independently. Okay. So if I wanted to show what something would cost with a 50% increase in price on it, that would be multiplying by 1.5. And then this would equal my $129.60. However, we're doing more than just a 50% because we're also putting an 8% tax on it. So really, you're taking this amount, you're multiplying it by 1.5, and then you're also taking this amount and you're multiplying by 1.08. So an 8% increase in the price of something corresponds to multiplying by 1.08. And you should see this. So, for instance, if I have something and I want to figure out what 8% of it is, right? What's 8% of that amount? You always just move the decimal to the left 2 points. So that's 0.08. So this is the increase, and then you're adding it to what the original price of the thing was. So if you pull out an x here, this is the same thing as 0.08 plus 1, which is then the same thing as 1.08. That's where it comes from. Yeah. So whatever the percentage increase is, add 1 to it and then multiply it by it. So, I mean, in total, we're adding 58%. So I could just say that x times 158 over 100, because that's 1.58, is equal to 129.6. Now all I have to do is solve for x, which is the original amount. And the way to do that is to divide by this, which is the same thing as multiplying by the reciprocal. So x is equal to this 129.6 times 100 over 158. So it's different than times 58 over 100. It's times 100 divided by 158. Yeah. You always multiply by the inverse of the percentage increase, thing. Okay. So if we were to do that on a calculator, 129.6 times 100 yeah, right? Exactly. Yeah. I'm going to assume, since this is probably a middle school or high school question, that we're not iteratively doing the tax. I assume that the percentage is on, okay, and this is why, because it's profit cost, right? So that's the amount of money you want to make profit. You're right that the tax is usually put on the sales price of it. Yeah. But yeah, does this come out to be a nice answer? Oh, it doesn't actually. You would think they would say before adding profit, then tax. Okay. Yeah, okay. All right. Yeah, you are right. Okay. This would be how we would do it if we're adding the percentages at the same time. If instead we were adding the taxes in order. So this is correct. He's saying we add a 50% tax, we add a 50% markup for the profit, and then we add an 8% tax. That's going to be x times the 1.5. That's the profit increase. And then times the 1.08 to equal 129.60. Plot twist, it's for a business class and the backpack is actually a cake, so it's food and there's no tax. Trick question! Yes, but you know what the difference there is? If the cake is prepared with an oven, then it is taxed. Did you know the sensation? I don't know. Well, everything has weird tax in England. But in the U.S., food, like grocery food, is not taxed. Usually. Actually, it depends on the state, really, I think. However, if the food is prepared for you, then it is taxed. And so the definition of preparing something is like putting it in an oven or like heating it. So I think they may have changed this, but at the time, if you went to Subway and you asked for your sandwich to be toasted, you would get charged tax. But if you didn't ask for your sandwich to be toasted, then it wasn't considered like prepared and you weren't charged tax. Yeah, it's prepared in the store. It's weird. Yeah.
Our tax is not that complicated.
I know, you guys have VAT, so it's super easy.
There is the cost of the item plus 20%. And so the price is just there. That is the price that you pay.
That is the price, yeah. Yeah. Ours varies by the state. It also varies by what it is sometimes. It's super weird, man. Our tax system's fucking broken.
I think there are some things that you don't pay VAT on, but it's not very many things.
Yeah. There's what they call the pink tax, because I think female, or what they call it, feminine products, or like, you know, what female health products are taxed, whereas male ones aren't. Or men don't really buy like hygiene products. I mean, we're just lucky if we brush our teeth. But women pay money on things. Yeah.
I think if something is a fundamental necessity, then it should not have tax on it.
Correct.
When I say fundamental necessity, I mean just this is a plain bottle of water.
Yes.
This is a cheap plain loaf of bread. This is a basic feminine product. That kind of thing.
Sure.
Things that are specifically required, or you will suffer.
Yeah, in order to live.
Or die.
Yeah. They call it the pink tax. Right? That's the whole argument they make. But yeah. But okay.
See, I'm not right wing twat.
Yeah, he's not that right wing. Speaking of right wing, some guy got inaugurated today. Did you see that? Like Melania looks like the Hamburglar.
Does she?
One sec, I'll pull it up. One sec. Let me just solve this real quick for a dookie. Yeah, $80. I agree. It probably was it was probably an iterative tax. Yeah, because $80 looks really nice. Yeah, that's great. Love that. Yeah, with the hat. Here, let's go watch the hat. One sec. What's it? It's swearing in Trump, and then we'll do your next question. Give me a second. Bro, yeah, dude, what is this image, bro, dude? Excuse me?
She looks like an assassin.
She looks like dude, I thought this was like a Mennonite or like an Amish person or something, bro. But people are saying she looks like the Hamburglar.
She definitely looks like a Mennonite, yeah.
Yeah, the Hamburglar.
I've seen that in a long time.
Right? Yeah, this has been a while. Yeah, Amish vibes. Yeah, it's a very interesting thing. Also, like, Trump swearing on any Bible just feels wrong. That man is not a very holy man.
Well,
not that any of us are. Like, I'm going to hell anyways. So.
Okay, I got something fun for you.
All right,
this was in relation to what we were talking about before. Just play it from that time index, though.
Okay, all right, let's play it. I think he did swear on the Bible, didn't he? Oh, so we got advertisements. Okay, wait. Okay.
Bloke went to Dogs as he walked in. He said, "Hey, my friend, have a look at this." Sorry, these. He had 5 of them. He said, "My God, man, how do your pants fit you?" Like a glove, yes.
What's the like a glove?
You can join in on That's the Future of Comedy.
What's the like a glove, dude? What? Where's that from?
Did I get the wrong time code?
Oh, well, give me the right time code. It made news that he didn't actually swear on the Bible. Oh, is that true? Uh-oh. All right. One sec. Let me finish the Darcy's question because I got him here. 5 fingers in a glove? Yes, Equity, you can say fingers in. Wait, fingers in got flagged? Excuse me?
Bring back fingering.
Bring back fingers. Yeah, fingers in. 5 fingers.
No, it's something they were shouting at the pub when I first moved here. They were literally just fully grown men running around shouting, "Bring back fingering."
Bring back fingering. Oh my god. The original contraceptive.
Yep, there we go. There's the right time code.
Okay, I'll put it after this. Oh wait, one sec. He's saying he didn't do it. Trump not swear on Bible. Oh, he took the oath of office without his hand on the Bible. Oh, dude, whatever. He just probably forgot, dude. Yeah, he just forgot, dude. This man's old. Whatever.
No, I've seen to do that.
Yeah. Okay, there are 800 students in a school. 45% of the students are male. If 30% of the male students and 25% of the female students play varsity sports, how many students play varsity sports? That's cool. Yes. Yeah, I did see Elon give the Roman salute. He's just autistic, dude. He doesn't know what he's doing. People think he's like dog whistling, like more Nazi Hitler stuff. I don't think he's socially conscious enough for that. He just doesn't know what to do with his hands.
You mean like this?
Yeah, he did the. We'll show the video after this. But yeah, he did the.
I've seen black people do that.
Yeah, I do like, I think the issue is if like, there's a whole meme about this, right? About like how high the hands allowed, how high like pet the dog versus not pet the dog. Yeah.
Hail a taxi.
Yeah, like hailing a taxi versus.
Then it's got the lyrics from that song.
Yeah, it's just. Oh, the Erica song.
I'll see if I can find it. I think I've got that meme somewhere.
All right, pull it up. All right. Yes, fascist salute. Yeah, there you go. Okay, all right. 45% of the students are male. So if 45% of the students are male, then we can say that 55% of the students are female. Well, maybe. Assuming there's only two genders. And if 30% of the male students play sports and 25% of the female students play sports, how many students? Okay, this is cool. Are you gendering the students? Unfortunately.
There you go.
Yes, this is the meme I'm talking about. Yeah, this is such a good one. It's the Erica song. God damn it. Call taxi, pet children, pet dog, rest. Call waiter. Oh my god, dude. This one is too funny. Was Trump gonna make a rule about there being only two genders? I think only two sexes. I think that's the key thing here. I do agree gender is a social construct. You can call yourself whatever the fuck you want. I don't care. But biologically, there are two sexes. I mean, technically, there's some weird chromosome shit that happens that sometimes a third one pops up, but it's really just two. You're either XX or you're XY. Whatever you want to call yourself or dress up as, I don't fucking care.
Neither do I, as long as you don't talk about it.
Yeah, well, I mean, you can talk about it, just don't force it on people. That's what I say.
Well, no, because I mean, it simply boils down to this: if you
can talk about it.
If you tell me you're Napoleon,
yes,
I'm going to send you to a hospital.
Yeah. Well, that is the new thing, right? You're allowed to say transgender is a mental illness on Facebook. That's quite a fucking 180 Mark Zuckerberg did in like the last week. Right? He got Dana White on his board. Why. He said that. Well, I know why, because he knows how the tides are shifting. He just plays wherever the tides are shifting. He got Dana White on his board. He said that tech companies need to restore masculinity, which I think is ridiculous. I was like, excuse me, like what? That's kind of bold to say that.
Odd.
It's just odd. Yeah, it's just odd, to talk about companies with masculine and feminine energy. That's just not. What? Why are we anthropomorphizing companies? They're the most anti-human things ever.
Especially social media.
Yeah. What? Yeah. That's okay. Okay. 45% of the 800. Cool. This is the number of males. And then if you want the males that play sports, that's 30% of that. So then this is male sports. Okay. Plus the 25% of the remaining 55% of the people that are female. Times that. And then this is female sports. Because this is females. And then this is female sports. Gold, what is DEI? Ooh. Oh dear. Sensation, you want to take this one?
I've forgotten.
Good, yeah. DEI
Diversity,
stands...
equality, and inclusion.
Diversity, equity. Not equality. I think it's equity.
Equality, right, yeah.
And inclusion.
Equity's a horseshit term anyway.
Yes, it is. Yes, there's a lot of companies that are getting rid of DEI.
If you get someone that's exactly my height, my IQ, I don't know, musculature, whatever, there will still be no equity between the two of us, because even if we are almost exactly the same, one of us is going to be better at something than the other.
For sure. I mean, we don't have equity in the fucking NBA. You know, we don't say like, oh, we need more 4'6" people in the NBA. Like that's not a thing.
Equity cannot exist biologically.
Right. Okay, yeah, one sec. The answer is Darsh's 281. Good job. Here, let me answer some other students' questions. Is getting rid of DEI a good or a bad thing? Like most things in life, there's pros and cons. Yeah, good job, Maduki. Again, the intention behind DEI, I think, was well intended, because you do want diverse workplaces, you do want diversity in cultures, in things. You know, if we admitted everyone into Harvard just off their SAT score, it would be the population of China, because for whatever reason, the Chinese do really fucking good at the SAT, and they're the best. But if Harvard was all Chinese students, it'd be a pretty shitty fucking school to go to, because you have no variation then. There's no culture. There's no diversity. It's fun to have people from different walks of life, because that's how really cool ideas form. It's by interacting with people that are different than you. So you do have to put some guardrails in place to kind of force that diversity. Otherwise, certain fields become dominated with just one demographic. You know.
But that's true for the same reason that all other fields are dominated by a particular demographic. It is biological.
It yes.
Just
Well,
so happens that the Chinese are better at taking exams.
Yeah, the Chinese. Well, and also they fucking cheat. So, you know, they're like the amount of cheating on those exams is fucking rampant. But yes, yeah, and again, it gets to like how granular do you want to get with the diversity? You know, sometimes it's just we just want equal men and women, and I'm like, cool, whatever. Yeah, I mean, I think that applies for some things, but other things. This is the big argument now in Los Angeles. Is I think 97% of the firefighters in Los Angeles are men, and the fire chief is a woman, and even more so, she's a lesbian woman. Like, they really went far on the fucking like spectrum of trying to really shift it. And nothing against lesbians, you know. One of my sisters is a lesbian. I don't fucking care. Like, lesbians are great, but the woman as a firefighter, there's a reason why most firefighters are men, and it's because to be a firefighter, you need to be physically strong enough to be a firefighter. And there are biological, physical strength differences between men and women. So that's why it is.
Significant ones as well.
It's significant. It's huge. There's a reason we have difference in men's and women's sports, because the times and the records and things are very different. So if you want the strongest, whatever, blah, 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 then that's going to attract a certain demographic, you know? Also racially, you know, certain races are taller than others. You know, I think the average height in, you know, some parts of Asia is under 5 foot. Do you want that person to be a firefighter, or would you rather it be, I don't know, a Samoan who's fucking massive and can, you know, I don't know, like carry big things out of buildings? Depends. So
I don't know, actually. To be honest, you actually.
But then maybe you want a small person to crawl in between the small spaces. Yeah, okay. Yeah, maybe there's both. I don't know.
No, because small people like me, who are quite wide and very short, we have a lower center of gravity. We can pick up more than Simone can.
Exactly. Yeah. And so the way you get rid of this is you just have a fitness test. You just have a physical fitness test, and you say fuck it to like putting on your application whether you're Samoan or you're a woman or you're whatever. It's just like, can you pass the fitness test, and then can you pass whatever the mental test, and then cool, now you can be a firefighter. Yeah, great. But when you start lowering the standards because you're trying to force some sort of diversity in certain fields, that becomes a problem. In other fields, again, if we're talking about, I don't know, people bagging groceries, there's not a big consequence there if we start forcing some diversity. Like, whatever, I don't care, you know. The military has different fitness standards for men and women, sure, but also men and women get put into different positions. I don't think many women are in frontline combat roles, or I don't think many of them are, you know, servicing tanks that are using really heavy things and whatnot. It's just different.
Actually, we found there were a lot of women engineers.
Yeah, sure.
But
Yeah.
Most women would not categorically. They would outright refuse to go on the front line. Why? Yeah. Because they're not dumb cunts. They know they will be targeted. That's disproportionately.
Oh yeah. That the opposing side is gonna be like, oh, they're those are the easy ones. Let's go hit them first.
And men are hardwired to throw themselves into danger to protect women.
We are. Yeah, no, it's a, for better or for worse, it's a thing. So, yeah, like Skilliam said, like anything else, you have to use it the right way, not abuse it. Diversity is good. Diversity at the expense of integrity and functionality is not. Correct. 100%. I agree. End of argument there with DEI. So I don't think it's right that companies are just, again, I see this whole Mark Zuckerberg thing, doing a 180 in like 2 weeks. It's so duplicitous to me. None of these people have any sort of moral integrity. They just go with what is popular and what's profitable. It's like the whole thing with, what was it, during like Pride Month? I think Target started like putting more rainbows and shit like in their store to be like, hey, Pride Month, we support Pride Month. And then the second it was like not profitable in Mississippi, they just got rid of it. It's like, okay, so you don't really support Pride Month, you just support profits, and if it's trendy to do so, you'll do it. Just fucked up.
Well, that's why it's on for a month.
Yeah. What's up, Famished? What up, dude?
The only reason Pride has a month is because you can just milk it.
Yeah. Messi says, I don't like any lesbians or gays. Well, okay. That's okay. You're entitled to like what you want. I say love everybody, you know. I know for religious reasons, certain people are not tolerant, I guess, of other people. I'm tolerant of everyone. Do whatever you want. I don't care. Mods, ban him. Yeah, it's okay, Messi. No, I won't ban you. Just you can have different opinions. I'm not a cancel culture type thing here. Just don't be don't show hatred. Hatred is wrong. You can say you disagree with things or you're not a fan of things, but don't hate people just for being a certain way. That's when it crosses the line, you know. Mods, it's okay, Darsh. It's all right. Yeah, again, he's fine. He can say whatever he wants. Again, as long as it's not hateful, I don't care.
It's kind of funny you mentioned that. I do try to
he's
stick
joking
with that.
Yeah. What do you mean sensation?
Well, because I try and stick with not hating people just because.
Yeah.
But then the English language is also quite complicated sometimes. So
Sure.
I say I hate the Chinese. Now,
I hate the Chinese.
The use of the assumption then is that I mean every Chinese person to exist. It's
Sure.
like, no, I only mean the mainland Chinese, and even then a subgroup of that. But the English language doesn't allow for that, so you have to say the Chinese.
You could just say I hate the Communist Party of China. That's cool.
No, because they have their enablers as well, who are Han Chinese.
Okay.
But even
I'd say
they don't say Han Chinese.
instead of like saying I hate a generic group of people that doesn't apply to all the people, you could say I do not like people that believe in this. You know, I think it's totally cool to be like I don't like fascists. That's cool. But if you say like I don't like Germans, you're implying that every German is a fascist, and that's wrong. That's where blanket statements become troublesome. Anyways, Famish says I might do some math in a bit while more co-working because I'm a terrible teacher unless I'm teaching myself. Oh no, everyone's a great teacher. But if God wanted to be, okay, this is, I don't know how much I'm gonna go down this road, Messi, because I want to teach math. But okay, he says if God wanted to be gays in the world, then Jesus is gay. No.
So is Muhammad by that logic. So is Muhammad. So just no.
Yeah, that math doesn't math, dude. The math's not mathing there, dog. I'm sorry.
And given the fact that one of the central tenets of Islam is subjugate little boys, you know what I'm saying?
Oh, is it? Oh, I haven't read much of the
yeah.
Quran. Yeah. Let's see if Ajner is here.
I've read it in Arabic. So.
Oh, have you? Can you read Arabic? That's pretty dope.
Well, yeah, I was in that desert for a long time, dude.
Yeah. Shandrick says, I think there's a language barrier. Yeah, there is. It's okay. Alright, if Ajner shows up, I'll do his. Bro, you forgot to complete the square on this one. Fucking funny. God damn it, dude. I'll laugh at that. That's funny. Famish edits. What's up, dude?
Huh?
Okay. Anyways, here, let's try to do, whose question is equity? Bob Ross, is you around, dude? Where's Bob? Where's Sir Bob? I know you're around, Bob.
You say fuck all for months, and then you just say blah, blah, blah.
I skipped one. Ajner. If Ajner comes by, I'll do his question. Otherwise, it's equity and then Dennis. Yo, Wagwan. Okay, let's do this one. Let's try it. I'm not on drugs, I promise. I mean, I wouldn't judge you if you were on drugs, you know, as long as they're not bad drugs, you know. Jeff says I am on drugs.
Everybody here is on mushrooms.
I would be a terrible stream. I don't think I'd have much fun doing that.
My God,
I never,
dude.
I never understand the kid. Dude, I have kids that talk about just getting messed up and then going to high school. I'm so confused. Why would you want to be fucked up at high school, dude? That sucks. That would be torture.
I told you that, didn't I? Where we got to sort of year 11, and then they were just people sitting in the back of the woodwork shop just drinking tinnies.
Yeah, that's too funny. Yeah, I've talked to some people talking about like sneaking water bottles of vodka and just getting drunk in class. And I'm like, what? Why?
Oh no, there was nothing subtle about this.
Oh
they were
no.
sitting there with
Terrible.
Tins of Fosters look like Tins of Fosters. They are bright blue with the
the
big
beer
F on
can.
the front.
Yeah, Foster's. Then we'll do this question. Give me a second. Yeah, Foster's beer. You talking about this one?
Yeah, that one.
Yeah,
so there's just nothing subtle about that, and
right.
In fact, that's a 330 ml can, isn't it? So
yeah.
bigger.
No, I know they do the big the 660s or something, or almost they're pints, I think, right? Or you get liters of these sometimes.
I think they were a pint. Yeah.
Are they called oil cans? Oil cans.
Oil cans.
No, that says 245. I don't know. Whatever. Anyways.
But yeah, there was nothing subtle about that. It was just the teacher just was sat at the front of the class, not giving a shit.
Twitch is ban hungry? Really? Is Twitch gonna ban me for putting a picture of beer on my stream? Are you serious? That's whack. That's wacko. Oh, we have some people in the chat, dude. Where did I go to university? UT and UCLA.
That was like 2 hours ago.
Oh, my bad. Okay. Okay, alright. You guys have fun in my chat. It's okay. You're allowed to believe whatever you want. Just don't hate people. Let's try to do this question from Equity. He says, Aaron has an empty 1x7 grid consisting of 1x1 squares, and it follows the process below to construct a pattern. Place an X in an empty square. If 3 or more consecutive squares in X, stop and do not add any more X's. Otherwise, go to step 1 and continue the process. Okay. Wait, what? Wait, how can you do this one, though? I thought if you do this, and then you do 2 more, then you have to stop, right? It makes me think too hard, yes. There's XXEX is equal to all of them together. Oh, okay. Oh, I see what he's saying. Wait. Endar, what do you mean by this? Sorry. Ice cold root beer. Yeah. Okay, sorry. Let me think of this. Okay. Place an X in any empty square. I think I see what he's doing. He says I could do this, then this, then this, and then do this. Is that what you're saying? Yes, thank you. Okay, cool. Dope. Love that. Okay, cool. The last pattern, yeah, if I had read an extra sentence.
Surprise, motherfucker.
Messed up, Aaron.
Yeah, I messed up, dude. Yeah, if I'd read the next sentence, I would have gotten it. How many different possible patterns can Aaron construct? Wow. Okay. And I can place it in any square. Fuck. Okay, let's think about how many total combinations there are. And then I think I want to do the total number of combinations minus the ones that I can't do. Does that make sense? Oh, you're getting 42 for this? Ooh. You got to find the pattern of the most you can end up within a row. Okay, well, let's think. So if I do this, And then I do this, and then I stop, and I do this, and I do this, and I stop, and then I do this. This is a valid one, right?
I think you have to add one more.
No, because then if I did... Oh, you're right. Wait.
Yeah, 3 consecutive.
Okay. So then this or this. Because that's 2. Uh-huh. But then I could also do this, right? This is cool.
Yeah.
And then this is cool.
Yeah, start from the beginning and just work out.
Ugh, man, that's gonna be so many.
So, 1, 2, 3, 2, 3, 4, 3, 4, 5. Yeah.
Is there an easier way to do this?
I don't know.
Yeah, it says I don't know. This I think is harder than the other question because this one's more of a. This is supposed to be easier because it's the Kaylee competition, not the Pascal competition. But there's less math here. This is more of a visual puzzle, right? Shantrick says it's 43.
I would just go through it all and just work out the final algorithm after the fact.
Oh, Shantrick says that Kaylee is harder than Pascal. Wait, that last question we did was grade 9? Damn. I mean, it's like grade 9 of the Einsteins, but I can't believe this is a grade 9 question. That's a lot. Do a binary 0 through 127, kick out an answer that has more than 5 ones in a row. Yeah. I know how to do this with code. We gotta do this by eye, though. Also, this is question 25, which means it's always the hardest question. It's the last one.
127.
Well, okay, because there's 7 spots, right? So each spot can either be an X or a 0. So that's 2 to the 7th combinations, which is 128. There's 128 ways you could just arrange the X's, okay? I'm wondering if I just subtract out the ways that I can't. Well, that's hard though then. Yeah, well, because like this is not valid. You have to kick out any question that has, he says, kick out any answer that has more than 5 ones in a row. Why 5? Yeah, you need at least 3. Okay. So I can kick out all the ways that we only have 2, right? How does that work? Is that 7 choose 2? For there only be 2 X's? So this is obviously not valid, right? So 7 choose 1. No, you can't do all zeros. You need at least 3 X's, and you can find all the 3 solutions because they must be XXX. Yeah. Okay, 5 in a row is the most you can do without hitting a 3 beforehand. Oh, interesting. Because there's this. If you only have 3 X's, they must be in a row. Yeah, exactly. So the way to do that, right, is that I could do this. So I like to think of it as like a block, right? So that's one possibility that you can't that you can do, right? That's a possibility you can do. That's a possibility you can do. That's a possibility you can do, and then that's a possibility you can do. But if I only have, so if I have 0 X's, 1 X, or 2 X's, I can't do any of them. So I'm gonna say that ways like can't do. Okay. I can't do 7 choose 1, right? I can't do 7 choose 0 either. Can't do 7 choose 1, and I can't do 7 choose 2. If there are 3, there's only let's see. I want to do this. Right? I could do these three. I could do these three. I could do these three. I could do these three, and I could do these three. So that's, wait, 1, 2, 3, 4, 5. Okay. So that's 7 choose 3 minus 5, right? I can't do 7 choose 3, except there are 5 of them that I can't do. Okay, let's say there was 1 then. Oh man. And then for 4 X's, well then there's this, right? 1 second. Only 3 can't be done. You're right. So wait, this can't be done. That's the same one. 2 can't be done. Wait, this can't be done. This can't be done.
It can be though. You can still end up with 4 in a row.
No. You have to stop when there's 3 in a row.
Right, but yeah. But you can still have 4 in a row.
No. Because
1, 2, this 3, 4, come back to 3.
Oh, fuck, you're right. Damn it. Yeah, because I could do this. Ugh. Damn.
Sorry.
Oh, Sensation, you ruined my parade, dude.
Disqualified.
Damn. So wait, 4 is possible then. Wait, they're all possible. Yeah, wait a minute. I think all these
minus 1 is possible.
Yeah, all the 4s are possible, right? Because I can always fill the last thing at the last second. Yeah.
1, 3, 5, 7.
I think with 4 X's there's an infinite. I mean, not infinite, but all the ways work. I don't know any way with 4 that they don't work. Now with 5, now things get a little trickier.
Minus 2.
So 4 and then 5. So let's just see. You could have done this, and then you could do this.
Mm. Yeah, so all minus 1, all minus 2, all minus 3.
Yeah. He says there can be 6 squared filled at most. I thought we said there were only 5 that could be filled at most.
6. It's 6.
Okay, 1, 2, 3,
all minus
4,
1, all minus 2, all minus 3.
5, 6. You're right.
How many variations is that? Yeah, so
I don't think there are any restrictions. I don't think there are any restrictions. Wait. I gotta think about how we did this one. 7 choose 3. I like that Endar. Yeah, Endar puts a good little thing here. He says, "Is there a pattern?" So he says, right, for the 4 grid, there's only 3 different ways. So if we did it for the 5, maybe we see a pattern. Could be true. Yeah, and then he says, that's smart, Endar. I do like that. Because if we get like some sort of pattern, then we're good for the then we can see something for 6 and then 7. This is called proof by induction. Like if I can show what it does for n+1, then I can show what it does for like n+2 and +3.
I was gonna say it's not just n-1, is it?
I don't think it is. Cause watch, let's try and do it. Let's do it for 5. Okay. This is for 5, I believe, right? 1, 2, 3, 4, 5. Yeah, okay, cool. And then just ignore the one over here. It's like, let's get rid of that one. Okay, for 5, let's see. So you could do this. Or here, let me just put a bunch of dots. I think I'm gonna put dots instead. Dots are our friend. Let's do this. Let's make the dots red. Right here. Let me just copy paste them. Okay. You need at least 3, right? So that's 1 way, 2 ways, 3 ways. Okay. And then with the combination of 4, so we have 3 dots equals 3 ways. With 4 dots, this always works, right? Because I can do this one, this one, this one, and then fill this one in. So this works, and this works. There's just 2 ways. And then I don't think you can do it with 5.
No. The maximum's invalid.
Yeah. Right.
Oh, wait.
He says 2 more with 4?
No, sorry. All is valid.
Well, okay, with 4 dots, right? I could have a gap here. Oh, you're right. Okay, sorry. So I could have a gap here. That's right. Sorry. So we could have that.
5 has 1 way.
Are you right? No, because look, the second sensation. The second I put this, then I already got the triple.
Yeah.
So you can't do anything with 5 dots. With 4 dots, yeah. So I was wrong. So you can do this. You can do this. You could also do this. And then you could do this.
Wait. 1, 2.
Oh no, he is right.
4,
You could do 5. There is your sensation. He's right. There is one way you could do it. If you do 2 here, 2 here, and then the last one. Okay.
There's one way to do the maximum value.
There's one way. Yeah.
And so then there's minus 1 way to do, yeah.
And then there's 4 ways to do 4 dots. Because you could do this. You could do this. You could do... No, fuck. Could do this. Or you could do this.
I'm sure this is bit shifting.
If there was more than one way to do 5 dots, I'd be concerned. I agree too. Okay, so let's see. So for 4 grids, so let's say so for a 4 grid, there were 3 ways. For a 5 grid, there was 8 ways. So doesn't really give me much hope.
N plus 5. What about the no one?
Yeah, Shantrick says I don't think there's a pattern. I don't think there's a pattern. I thought it was cool just do it 5 ways. I want to see what happened.
This feels like bit shifting somehow.
4 is Popple. 5 may not be a connection. Oh yeah, he says, but for a 7x1, 7 is not possible. Correct. Yeah. Fuck. Okay. I want to make sure I have time to do Dennis's question. Do we want to get the answer for this one? Chandrick says yes. Okay, let's see the answer. I'm curious. I do want it. I do want the answer. Again, with these questions, I'll give it like 10, 15 minutes of struggle. If I'm not seeing an epiphany anytime soon, I like to see at least just for the sake of time. Also, if I'm not making much progress. The last one I was making progress, so I was cool with trying it out a little bit more. Not really making much progress here. I'm just getting frustrated. Oh, Christ. Okay. Case 1. Okay, so they did do the same thing here. Do you see how they did 3x's, 4x's, 5x's? You gotta count all the cases? Yeah.
Disqualified.
That would suck, dude. I don't want to count all the cases. How do they do this on a math competition? I mean, did we have this? Did we have this? The answer was 43, though, by the way. Did you get it by counting them, or did you just guess?
It says 81 here.
Very tedious. I counted. Okay, all right, that's okay. I like to see if there's a nice, beautiful math solution to it. It's very cool. Life, the universe, and everything. Yes, Lou. The answer is. Oh, interesting. Ah, that's cool. What was your prompt, though? How did you get F of whatever? Yeah, I was hoping for a more clever solution, Endar, as well, but yeah, there aren't. They're not all clever, unfortunately. Sorry, Sensation, what'd you say? What'd you get?
I just dumped it in.
Oh, you just dumped the question in and just said go for it? Yeah, it sometimes gets that right, sometimes it doesn't. This is the stream that never ends. We have math problems on end.
Yeah, here you go. That's the right time we got this time.
Okay, here, let's go watch this joke real quick. And then we'll do Dennis's question.
When you go rogue, you
What?
make your own.
Am I getting
fun,
advertised for fucking nicotine pouches? God
no
damn
matter
it.
what it looks.
Our on Preston train station, this announcement, come on. Ladies and gentlemen, on platform 4, the next train is an express to Carlisle. We advise passengers to move away from the yellow line at the edge of the platform, as they may get sucked off.
Is that a joke about Carlisle?
Bring the train on! I'm ready, bring the train on!
What's the joke? What's the Carlisle joke there, Sensation? Isn't that where Noise is from?
I can't remember, you mentioned it earlier on.
I think he's from Carlisle. Okay, Shandrick says you have to practice these types of questions to realize if they need counting or an elegant solution so you don't waste time in the contest. Cool. All right. I understand that. That's cool. Again, this is where the math part becomes kind of more of a game. Sometimes there's a cool way to see a pattern. I remember in one of these we did way back. Where was it? Way back. We did one of these questions, and I was very happy because it was like a cool little pattern. It wasn't this one? Which one was it? This one? No. Oh, yeah, like this. This is a question where I feel like we were going to have to count things, but then you end up finding that there's a cool series representation of it. Yeah. This was a cool one. So sometimes there are nice little mathematical solutions that don't require you counting up all the different solutions. Maybe if it's multiple choice and you see the number of ways is like stupidly big, then you know you're not going to count them. Did someone say cool series?
That's dope.
Yeah, we love cool series. Speaking of cool series, got are you helping out with that, the infinite series thing, Pen, or are you mainly helping out with the linear algebra? But yeah, e to the 2I pi is doing a infinite series mini lectures, I think, which is pretty cool. Oh, there aren't multiple choice questions in. Oh, interesting, for the Kaylee series. Interesting, I didn't know that. Just lineage, cool. Series are cool. I love series. Series are dope.
That's dope.
All right, let's see. I think Dennis has a cool question. I think it's a differential equations question. Integrating factors and special substitutions. Find the solutions of the following equations. He wants this one. Oh, this is cool. Is this where I multiply this by something that's like e to the something something, right? That's what I do sometimes. All right, let me move this over. dy over dx is equal to y squared 1 over y plus x. Oh, yeah, good to see you, dude. Take the pupper out.
That's near Doug.
Substitution. Oh, is that one way to do it? That's a hearse. That's a hearse? What's that's a hearse?
Horse.
Oh, the horse. That's a horse.
That's near Doug. That's a horse.
His dog is quite big. What's his dog's name again? Sorry. What's it? It's like Bo or something. I should know this.
Scooby-Doo.
No, Scooby-Doo. No, God damn it. Oh, Penn Center's dog. Oh, man. It's a cool name. I remember it now. My memory's shit these days.
Yeah, I can't remember either, and I really should be able to.
Because he also has his bot, like, sometimes act in the
Reese.
voice of the dog. Reese! Yes!
That's dope.
Reese. That's it. The Reese bot. Dennis says, I figured out it was dependent on X. Yeah. If mu equals mu of x, then d over dx ln mu x is the formula. Yeah, so I mean this sometimes happens in differential equations. Sorry, what am I looking at this for? It's all about just like figuring out what the trick is with what the thing looks like. So if it looks like this, then it's this. If it's homogeneous, you do this. Blah 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 blah. I think this one is because your test said it was. It says integrating factors and special substitutions. Oh, thanks, Zach. Zach said he coded a simulation to the last problem. It is indeed 43. Yeah, so this one, yeah, again, you could brute force this, right? You just tell the computer to go through all the different ways to place X and stuff. Oh, you did it stochastically. Solve it for 8 and 3, and I'll see if OEIS has it. Let's see.
Sorry, that's kind of funny.
What's up?
It's like, you're really good at coding when you're not on stream. See, that's true for me as well. I just sit there staring at the screen for like an hour.
It's like stage fright.
Yeah, it's weird. It's like I know what I should be doing, but can't do it. And
He
it's
said
like,
he did,
what
Zach did it one-handed.
what,
What were you gonna say? The sensation? You feel like you can do it, but then what?
I'll be sitting there doing something just really simple, and it's just like, no.
No.
Oh no.
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 No. Man, this is bugging me out, dude. Is it not like, I think there's like always some substitution where you say like e to the something of this is equal to this. Now try while holding 2 of your children. Wow.
Learn to type with your feet.
Yeah. I had a friend that could beat people in Street Fighter with his feet. He was my roommate. He was like one of the best Street Fighter players in SoCal, and he would beat people using his feet on like the controller. It was very impressive. Okay, thank you. Mu equals e to the integral of p to the x. Let me look up what integrating factors is real quick. Sorry. I'm gonna learn with you guys. I forgot. Yes. Okay, this is what I want. Suppose we have the first order differential. Oh wait, this didn't pull out on the right thing. Oh, this one is not linear. He says not linear yet. Oh man, this is a very annoying watermark. He's like, since you weren't asking, it's 418.
Me studying tech might be a bad career path. Well, if you learn to think like an engineer, it'll be easier.
Yeah. Yeah, it's the process you learn.
Go work on a car.
Go work on a
Problem
car. Wait, is P a function of X? Oh, P and Q are functions of X only. All right, one second. What do we got here? Oh, I see. Wait, what? Oh, but no, we're okay, right? Wait, because this gets me dy dx is equal to y plus xy or xy squared. But I don't think I can do that, right? I do want to get into engineering. Only reason I want to go to community college is to learn math. Yeah. Community college is a great place. Also, the education's better there because you're not dealing with 300 people in a big lecture hall. It's probably like 20 or 30, and it's a lot cheaper. But yeah, to get the math skills up. And then I say go to university for the higher level courses. Dun, dun, dun. Let me see. What does ChatGPT do for this one? Reorganizes the terms, groups the dx and dy, and so it gets... Okay. So it gets dx by itself. Interesting. All right, let's see what it does here. I'm just curious. Well, actually, no, we can leave this. Wait. So that's y plus xy squared. So then dy over y plus xy squared is equal to dx. That's not what they get, though.
Wait, is this differentiation or integration?
It's integrating. We're integrating this.
Okay.
I think ChatGPT is making some mistakes here, dude. They sometimes do. Let me see if that's right. Okay. 1 over y dx plus x dx minus 1 over y squared dy. Okay. Alright, this is just dumb. Wait, one second. I can just move this over and get that dy over dx equal 1 over y squared dy over dx. Oh, instead of a negative? Yeah. 1 plus y plus x, right? And then it says rearrange. This is weird. Okay. Let's multiply this y over y. Let's get 1 plus xy over y. Oh, okay. Uh-huh. So then dy times y over 1 plus xy. One over y squared is equal to dx, right? Looks like you can make the equation exact. How can I do that, Zone? Multiply by e to the x. Or on like both sides. That is all topsy-turvy. I get to here so far. I'm cool with this. And then you say multiply by e to the x? Or you say multiply this beginning part by e to the x? Oh, from the original equation? Okay. Send me a DM. Cool, thanks. Let me check it out. I don't know what the technique of exact equations are. Yeah, again, my math knowledge kind of tops out at DiffyQ. DiffyQ is... It's all these just tricks. Let's see what Dennis did here, though. It said m was equal to 1 over y plus x. N is equal to negative y squared. Negative 1 over y squared. Oh, okay. Let's see where this comes from. dm dy night Shantrix. Yeah, we've been going pretty late. Negative 1 over y squared. Okay. dm dy is that. Oh, I see. If mu equals mu of x, then ddx of ln of mu. Alright, sorry, no. If m... Well, your mu's and your m's look the same, Dennis. It's starting to mess with me. Or sorry, no, sorry. Your mu's look how I would draw an m. It's okay. Yeah, no, it's okay. You have like a really long tail in the front of your mu. U is e to the x. I have never seen this before. Or maybe I have seen it, I just forgot it. But I guess this is some trick that don't remember. Differential equations is all just tricks. It's all just knowing like, oh, if it looks like this, do this. Exact differential equation. Oh, okay, this is, yeah, all right, here we go. This is what I'm trying to look at. Okay. M of xy plus n of xy dy dx equals 0 if and only if m of y is equal to n of xy. So the partial derivative of n with respect to y is equal to the partial derivative of n with respect to x. So I assume that's what you're doing here. So you say, oh, okay, because this looks like, so I need the original equation up here. Right, okay, if we divide by dx, this is obscure, it's okay. Then I have 1 over y plus x minus 1 over y squared dy dx is equal to 0. This is the same thing as y prime. And so you're saying that m is this? Okay, cool. And that n is this. And it's not since the partials are not equal. Thanks, Zone. Yeah, okay. Okay, cool. Right, I get this. This is, yeah, partial n with respect to x. Okay. So, you get that they're not exact. Okay. So if it's not exact, then you're saying you got to multiply by something to make them exact? Is that basically all you're doing? Like, where does this step come from? You're kind of like forcing a power rule, I guess, right? Or forcing a product rule, I think, right? Forcing a product rule. Which is, you know, kind of akin to, again, completing the square. You're forcing a perfect square trinomial. Uh-huh. Yeah, I haven't seen this part in a bit, but okay. Okay, so then you multiply through by e to the x. Cool. Got you. All right. So now, let me just copy this so I can see this. Partial m, partial y. Ah, I see. It's just e to the x over y squared. Cool. And then partial n, partial x. Cool. Okay, so now since they do equal each other, f here? Wait, sorry, why do we have f here? Equals to the integral. Okay, e to the x. Oh, and then this is a integration by parts, right? Okay, yeah. You do a very quick integration by parts here. That's okay, cool. Let c equal h of y. Okay. Okay, these go away because you're not doing derivatives. H prime of y is equal to 0. So is some constant c that doesn't depend on y. Okay, then I say we go up to here. Mm-hmm. Oh, okay. Damn, this is elaborate, Dennis. It took me through quite a memory hole of Diffie Q, dude. This is the end of Diffie Q. This is Wow. Okay, but what's wrong with this question? There's just like a... Do you say there's a minus sign wrong? One sec, what do you say? Wolfram gave me the same thing. It was just it was C plus e to the x instead of C minus e to the x. So you're talking about this. Minus sign off somewhere. Okay. Yeah, that is different though, right? Those are different answers. DDY has to be DDN of X. Oh. No, that works. Fuck. I'm seeing if this mind sign made a difference here, though. H prime y is 0, so h of y equals 0 for some constant c. Are we going from here up to here then? Okay. I don't see an equal sign here, but then there is an equal sign here. Why? The reason we went from plus C to C is, I don't know. That's probably our mistake. I was like, how did we go from this step to this step? Is it supposed to be just equal C? Okay, wait, the function f. Oh, I've hit the max time on this. One sec, I gotta refresh this. I hit once I hit 3 hours on this, it gets upset at me. Okay. Okay. Yeah, I'm just trying to understand why the equals C happens. Because, I mean, that's your difference. Call it positive, negative. Okay, cool. Is this equal to 0? And then, so then when you move it over, it should be equals minus C? Because, wait a minute. If... Because then if you pull this over, make this minus C, right? Doesn't that kind of fix your problems a little bit? Oh, he says the answer in the paper is correct, but so Wolfram Alpha is wrong, which does happen. Oh, he put it in Wolfram Alpha, and it is correct. Okay, so maybe you put something in wrong with Wolfram when you were doing it. Yeah. This is cool. You do it like with it's called a potential function. Huh. Yeah. Okay. If I like baby ChatGPT to go through it, I do also get the same answer as well. If I tell it like, hey man, I need you to use integrating factors and stuff, please. It's pretty cool. I want to go through this actually at some point. I'm not going to do it on the stream because it'll take time, but Zone Ranger's suggestion of, hey, multiply by through e to the x at the beginning did help it. It did check for it to be exact. This partial m with respect to y equals partial m with respect to x. Then it computes the partials. And it says there's a potential function. I think this kind of relates, honestly, to physics at this point. Such that partial phi with respect to x is equal to m and partial... Yeah, man, where is this? Where have I seen this before? Ooh. I feel like... Is this the same thing with like Lagrangians and Hamiltonians? I remember seeing this where you start like flipping the partials. And then you do partial m with respect to x, which should equal the same thing as partial n with respect to y. Mm-hmm. That's cool. And then once you have that, you set this equal to a constant. Mm-hmm. Cool. Okay, cool. Cool question. I like it. Endor says he solved it by using u equals 1 over y, which makes it first order linear, can be solved. Okay, cool. Definitely on my harder end of differential equations. I appreciate people just chilling out while I just had to take in a lot of information there. I was like, excuse me.
Well done!
Yeah. Good job, Dennis. I appreciate that.
And then
Exact
there's just me
differential
that didn't
equations.
recognize Which is
What's up? What's up, Sensation?
And then there was just me that didn't even. I had to ask the question: is this differentiation or integration? Because I didn't even realize the difference.
Well, you see dy dx and they're asking for y. It means you got to integrate at some point.
I remember.
Yeah, you're welcome, Dennis. Thank you for teaching me. I've learned this before, probably like 15 years ago in my college DiffyQ class, but Very rarely do I have students asking that high of a level of DiffyQ questions. But that's cool. Exact differential equations are just ones that have associated potential functions. I feel like it's the same thing with a Lagrangian and a Hamiltonian in physics. I feel like it is. Lagrangian. Hey, what's up, Obi? Oh, motion. It just reminds me of this. I guess it's derivatives or something else. Or is it Noether's theorem? What is that, dude? Is it Noether's theorem? Emmy Noether? No, maybe it's not her. I started seeing some similarities to physics. Yeah. But I remember doing this. Like finding potential functions, and so long ago. I haven't done this in forever. A rose by Emmy Noether's name is decorative. By any other name? Yeah, that's a good one. I want to say it was something with like partials. But the partials are opposite. Or maybe it's Hamiltonians? That's how that works? Oh, never mind. Yeah. Yeah, that has to do with like time derivatives. That's what I'm thinking about. You do dHdP is q dot and dHdQ is negative p dot. Dr. Gold, Lagrangian Hamiltonian reading group when? Oh man.
Oh no.
That would scare me. I haven't had to do that since my grad school classical mechanics class, which was 2012, 13 years ago. Yeah. I'm sure, honestly, it would probably come back, and I would appreciate it a lot more now, because I understand a lot more of the math than I did when I was in grad school. But yeah, this is kind of the stuff it goes back to. It's like dFdq dHdP minus dFdP dHdQ. It's something like this. This to me is kind of what this potential function exact stuff reminds me of. Oh, cool. Stellar properties and astrophysics. Ooh, extra galactic stuff. That sounds fun.
That's dope.
Yeah. Anyways.
Was that the news thing about going to Mars?
Yeah, well, Elon blew up another rocket trying to over the Caribbean or something. Fuel line burst or something.
Yes, let's blame the non-engineer for the engineering mistakes.
Right, yeah. Oh, he's the finance guy. Let's see. I think that's all the questions for today. Did anybody else asking more questions? Sorry, I'm like exhausted. We've been streaming for 3 hours. No, that's it. Okay, cool. If that's it, let's end the stream off. Yeah. All right, cool.
That's dope.
Thank you everyone for coming to Actual Education Office Hours today. I had a fun time working with all you guys. Thanks especially for... I had a lot of really tricky questions today. That DiffyQ at the end was fun. Made my brain go through some mental gymnastics. I need my brain to like chill out for a bit now. And yeah, I always like the math challenge questions. That second one, the Kaylee question, was not so nice because it was just manually counting shit.
You done messed up, AA Ron!
I didn't want to do that. But the first one was really cool. The one with the triangles and then going to there was like a completing the square aspect to it. This one, I really enjoyed this question. So thank you, Shantrix, for this one. We got really close to solving it by ourselves, and then I had to look at the solutions to see that we needed to just plug stuff in and just manually get it with completing the square. It's really cool. Okay. Our next stream will be tomorrow. That's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on by if you want to get some help with math, science stuff that's going on. We have a whole calendar of people that are also streaming math and science stuff this week. If you ever want to figure it out, there's a website here. Let's see who's on. I don't think anyone's on after me right now. Yeah, well, we went a little bit over time, which is okay. But tomorrow, we will be on at 4 o'clock Pacific, and then Zach will be doing Infinite Series Act 2, starting about an hour and a half into our stream. So come on by for that. And then if you haven't already checked out, Penn Center and Zach are doing a linear algebra course that they just started. I think the first one was today. The next one will be on Wednesday morning. So go check out their channels. There's all the math streamers. And yeah. Oh, Phobos code roast of Yagdargo? What is this, Phobos? Anyways. Okay. Cool. Let's see. Who do we want to go raid? Let's go raid somebody. Who is streaming? Yeah, I was there for some of it, Femvox. It was pretty cool. Linear algebra is a very useful math class to know, especially if you want to get into like coding or anything video game related. A lot of that is linear algebra. It's a lot of matrices. It's a lot of solving a bunch of equations at once. Let's see. Curly fries versus burgers. Why not both? Okay, let's go raid somebody. Who's streaming today? Not very many people on Monday today. Oh, it's a holiday. That's why.
Oh wait.
Okay.
Did you see, before you go? Did you see this?
How milk is sourced according to vegans? God damn it, sensation. Just beating the cows. Is Moo Hoodles on? Is she on? Let me see. I like Moo Hoodles. Yes! There she is. Well, her stream starts in 13 minutes. But whatever. We'll go say hi to her. Go hang around. Go say hi to her. Otherwise, have a wonderful rest of your, what is it, Monday? Great start to the week. And come on by tomorrow. We'll be doing more math, more science, hanging around, and stopping by for Zach's Infinite Series question. Infinite Series class. Sorry. Okay. Cool. Peace out, guys.
Bye, everybody.
Bye.
But we will be starting off with some space news, just a heads up.
All right, Sensation.
We can definitely do
I'm gonna go run later. Let's go
Yeah,
exercise, dude. Let's go walk around a little bit. No?
Because we're starting out.
I should
Oh my
have.
gosh, actual education.
Yeah, come on.
Thank you so much for rating.
Let's just do it.
We do have
Let's do
ads
it.
starting
Take a
in
nap.
minute, just
Drink
a
your
heads up,
coffee.
So we can
We'll
get
go.
them out of the way at the beginning of stream. But how is
Yeah,
your
I need to,
stream?
I
Feel
definitely
free
need to
tell us all
exercise.
about it.
Seriously,
You
it's
need to
like-
wait and rest. Take care of yourself. If y'all are
I don't know
not
what
following-
happened because I started eating normally, and then I felt myself get fatter. It's really very strange because
No, I did too,
obviously
dude.
I don't eat, and I got fat, and I just expected that I eat normally, and everything will come back to everything will slim down. This is not the case. My
No,
back
the
hurts.
the problem is also as we get older, dude. Like metabolism just slows down, and we just get like screwed on like all fronts.
Speaking of which, speaking of age,